Un desestabilizador. Ey, ey, hola, hola. Ey, 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 ey. Hola, hola. Ey, 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 ey. Ey, 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 ey. Ey, 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 ey. Verde.
Sí, ya está.
Bueno, buenos días y bienvenidos a la Escuela de Ingenieros de Caminos, Canales y Puertos de la Universidad Politécnica de Madrid. Voy a cambiar a inglés ahora para que más gente me entienda de la audiencia. Welcome, all of you, to our school. We're in a civil engineering school that was the first in Spain, and we were founded in 1802, so we have a long history. But as you can see, we don't cling to the old appearances. And we're here for a very modern journey that we will take today. We are going to listen to many very interesting presentations on. Now you know. We're always recorded, but now you explicitly know in this case. Anyway, I just want to welcome here. Welcome to the school. Get to know it, get to know us, and we hope that you'll be visiting often as you want. And without further ado, I will leave the podium to Miguel Núñez, who is from the community of Madrid, and he's responsible for very interesting projects, and he will give the welcome. Welcome.
Bueno, en primer lugar, agradecer a la Escuela de Ingenieros de Caminos, a Manuel Romana, que aparte de profesor en mi etapa de estudiante en esta misma escuela, es amigo, fue mi director de la tesis doctoral, le conozco desde hace muchísimos años. Gracias por invitar a la Comunidad de Madrid, gracias por invitar a la Dirección General de Infraestructuras del Transporte Colectivo a participar en estas jornadas tan interesantes y que veo que han tenido una afluencia muy exitosa. Permítame que encuadre la Dirección General de la Comunidad de Madrid y que haga un pequeño apunte sobre los modelos BIM que nosotros estamos desarrollando dentro de nuestros proyectos y obras y el desarrollo futuro en los gemelos digitales. Nosotros en la Comunidad de Madrid tenemos muy diferenciadas dos tipos de actuaciones, unas muy relacionadas con la metodología BIM y otra muy relacionada con los gemelos digitales. En el primero de los casos, la metodología BIM está más asociada a la propia Dirección General que represento desde el año 2019, debido a que nosotros tenemos encomendadas las competencias de redacciones de proyecto y ejecución de obra. Sin embargo, nosotros no tenemos encomendadas la conservación y la explotación ordinaria de estas infraestructuras, que una vez que están finalizadas por parte de la Dirección General, se las traspasamos a la compañía Metro para su explotación, las ampliaciones de Metro, las ampliaciones de las líneas de Metro, y por otro lado, al Consorcio Regional de Transportes le transferimos los intercambiadores. Nosotros en la Dirección General de Infraestructuras tenemos encomendadas el proyecto y redacción de estas ampliaciones de las líneas de metro y de los nuevos intercambiadores que estamos ejecutando. Actualmente nosotros hemos finalizado y hemos entregado al uso público la ampliación de la línea 3 en el sur de la Comunidad de Madrid, entre Villaverde Alto y El Casar. Estamos ejecutando actualmente la línea 11 entre Plaza Elíptica y Conde de Casal, una obra de enorme envergadura, de 500 millones de presupuesto, que se ejecutará con tuneladora que está ahora mismo viniendo hacia la ciudad de Madrid. De hecho, esta noche, en el día de hoy, se va a hacer el traslado de la cabeza de corte de los transportes especiales que vienen de Alemania a la Comunidad de Madrid, máquina que empezamos o que esperemos que empiece a trabajar el 2 de marzo. Y por último, estamos ampliando la línea 5 desde Alameda de Osuna a las terminales 1, 2 y 3. En estos proyectos, nosotros lo que hacemos, lo que incorporamos, es una metodología BIM. Nosotros lo que incorporamos en los pliegos de redacciones de proyecto es que todos los proyectos se desarrollen con este tipo de metodología. Y implicamos no solamente a la autoría del proyecto, a la redacción del proyecto en la fase inicial, sino que exigimos que durante la ejecución de la obra, tanto la UT constructora como la dirección de obra y la asistencia técnica también tenga incorporada esta metodología. Y exigimos en los pliegos dos figuras importantes, el BIM Manager y el BIM Modeler. Una vez que nosotros terminamos estas infraestructuras con este modelo de BIM, que es participativo, que es colaborativo, porque es un proceso en el que nosotros participamos de una manera muy constante, trasladamos este proyecto a la compañía Metro, que es esta la que tiene que desarrollar este gemelo digital y que en base de este modelo BIM. Nos acompaña, ¿no? y va a intervenir en la última parte de la sesión 1 el jefe de unidad, Salvador Ruiz, que podrá explicar de una manera más detallada cuál es la implicación de la Dirección General en esta metodología. Nosotros tenemos puesto como hoja de ruta un calendario a corto, medio y largo plazo en el 2030 para que esta metodología BIM esté completamente implantada en la Dirección General. Y la hemos ido adaptando. Es verdad que en el año 2021 empezamos con una metodología o con unos requisitos muy exigentes y nos hemos dado cuenta que quizá nos hemos pasado en las exigencias y tengamos que bajar un poquito el pistón. Nos vamos, o sea, no somos inmovilistas. Si vemos que nos hemos equivocado en las necesidades o en las exigencias que pedimos, lo vamos a ir modificando. Álvaro Ruiz podrá comentar o comentará cuál es la implicación, cuáles son los objetivos a alcanzar en el año 2030 con respecto a nuestros proyectos y cómo hemos ido modulando estas exigencias en el modelo y cómo vamos a enlazarlo con los modelos digitales una vez que nuestras obras estén finalizadas y se la entreguemos al explotador. También nos acompaña la subdirectora de proyectos de construcción, Marina Montes, que también es experta en toda esta materia y que luego durante el café podrá resolver cualquier duda que tengan ustedes sobre cómo lo estamos implementando y hacia dónde queremos ir. De nuevo, gracias por la invitación a la Dirección General de Infraestructuras, gracias a la escuela, gracias especialmente a Manolo y a José Miguel. Doy la palabra a Ignacio González. Gracias.
Bueno, buenos días. Me uno a los agradecimientos a la Dirección General y a la Comunidad de Madrid por participar en este evento. Para darle también esa dimensión internacional, voy a hablar en inglés ahora. So this is again an event promoted by EUCEDIC, European Center of Digitalization for Infrastructures and Cities. This is a joint initiative of 5 European universities together with high-tech companies. And our mission is to provide education and training, to foster technology transfer, and to grow up business ideas, but also dissemination and networking. And this is the reason why we organize these events. In Madrid, we have organized 5 thematic events so far on digital twins for railway technologies, road technologies, logistics, ports, and mobility. And this is the 6th on tunnel engineering. I must confess that it touches my heart a little more because I'm a geotechnician after all, and there is a lot of geotechnics behind tunnel construction. But apart from my personal interest in the subject, I think that tunnels are excellent drivers for these technologies in civil engineering and infrastructures. Because when you are operating a tunnel, you have a very long infrastructure with a lot of things to control and a lot of automators. You need to control air quality, temperature, and you must guarantee the safety and the security, check accidents, traffic jams, etc. And when you are building a tunnel, especially if you are using a TBM is probably the most fascinating robot that we can find in construction nowadays. There are plenty of sensors and plenty of automators. They start to be intelligent, but we think that in the future, they will be much more intelligent. Not so intelligent to take decisions themselves on where to tunnel, but at least on how to tunnel. And talking about TBMs, and this is the reason why we wanted to have Community of Madrid. I must say that Community of Madrid was a leader worldwide in the introduction of TBMs with the extension of subway lines. And I also like to mention a professor of this school. Unfortunately, he passed away a few years ago, Manolo Melis. He was one of the leaders of the use of TBMs in the world. And I remember once that he said something like, okay, if you want to create a high-speed railway line from Madrid to Galicia, Galicia is like 600 kilometers away from Madrid, don't spend time, resources, and efforts with a lot of embankments, excavations, and bridges. Just take a TBM from Madrid and dig a 500 kilometers long tunnel. Of course, we laugh. This was 2007 or something like that. But last week, we heard that Elon Musk, he proposed to cross the Atlantic Ocean with a tunnel from London to New York. As I said, I'm a geotechnician, so I'm a little skeptical about this idea. But I think that we must somehow dream. We must think the future. Because if you look at the Earth, at this planet, there are like 4 spots that are a huge provocation for humankind and civil engineers to do something. These are the two canals, Panama Canal and Suez Canal. This was solved in the 19th century, but we still have the Bering Strait between America and Asia, and of course, the Gibraltar Strait between Africa and Europe. I don't think that this will happen this year. I don't think that this will happen this decade. But what I'm sure is that the day it will happen, we will have very intelligent machines that we will incorporate artificial intelligence, edge computing, and a lot of sensors to do that. So that is the future that we will come. I don't know when, but to explore these ideas, I hope that you will enjoy this event. I would like to thank all the speakers, the attendees, people online also. I would like to welcome the students of the learners of the third cohort of the Master on Digital Twins for Infrastructures and Cities. And I would like also to thank Bentley System, which is sponsoring this event. This is a leader company in providing software. They are also partnering us with our triple mission. And when I talk about intelligence, you know, this means that you need a brain and you need neuronal connections. So we need hardware and we need software. We need models and we need the software that embed that models. So I think that this is the future. Enjoy. And let's start. I must apologize. Part of in the first block, some sessions will be in Spanish, some sessions will be in English. So take advantages of the time to improve your Spanish or to improve your English. Okay, thank you. So, and the first speaker, usually we gather academia, industry, and administrations in these events. And we also showcase what we are doing at this school. So it's my pleasure to introduce my colleague, Salvador Senent. He is professor of tunneling and BIM at this school. So I think he's excellent because he's bridged these two worlds, the world of tunneling and the world of modeling. Salvador, the floor is yours. Thank you.
Okay, good morning. I'm going to give a presentation about how to extract, we are able to extract information from the site, either to process it and to compute, for example, geotechnical parameters, or to introduce the information in a digital model or to generate that digital model. The presentation is a little geotechnical, but it's the first step of modeling. I'm going to present 4 cases or projects. The first 3 are closely related to the characterization of rock masses. I don't know why, sorry. Okay, we will prepare in the presentation. Okay, the first 3 is closely related to characterization of rock masses. And the 4th is about the use of drones to generate a digital model. Sorry. So with the first is identification of rough discontinuities on the tunnel face. We use the structure from motion technique that combine different photos to create a 3D model. And this, for example, is a 3D model, but it's a point cloud model. We have the advantage that we don't need to get close to the face, so it's safer. This is the workflow of the methodology. In a simple way, we take photos, multiple photos from different positions, also with a high overlapping. Then we use a structure from motion software to create the 3D model. For that, we need to orientate and scale the model, so we obtain true orientation of the discontinuity set. And for that, we use a portable orientation template. And then we use the model to identify discontinuities and also to visualize on the model the discontinuities. So this is an example. For example, this is an example of a tunnel face with the position of the cameras. We use a standard camera, and it was our first time. We only do 200 photos. Wait for the next slide. This is an example. And this is an example of the results. We obtain a model with millimetric accuracy. And also we can see the discontinuities families on the model. So for example, in this case, if you use a compass, for example, it's difficult to recognize or to identify, sorry. It's not working. No? Yes. No, it's not possible. Okay, the red family in the upper part that is difficult to identify if you use, for example, a compass. And also we can analyze easier the families. And here we study also how many photos we need to create the model. And the result is with only 5 to 10 good photos, we can create a reasonable model for our purpose. In this case, to identify discontinuities and orientation. So depending on the model, you could maybe need more photos. Okay, now the second case, so the second project is a project I work with my colleagues and also with the company GeoConsul on developing a methodology to identify and characterize discontinuities for rock slope. GeoConsul uses the rock and soil hazard rating system to evaluate the condition of a slope, for example, on roads, and the necessity for intervention. The project obviously is based on the use of drones. We need to prepare the flight and also to take the photos. It's possible to take photos with the drone, but also to record a video and then obtain the images from the video. And from these photos, we generate the model, again, with the structure from motion technique, and also it's a point cloud model. From this point cloud model, we can extract directly, and also in an automatic way, the cross section, and for example, to compute geometrical parameters, like the width of the road, the height of the slope. The previous index uses also geometrical and also geotechnical parameters. This is one part of the project, our work, and this is the other, the identification of the discontinuities. This process, the step for this process first, we need to, apart from do the photos and to create the model to identify discontinuities, we need to carry on a coplanary test to identify pseudoplanar families. Then we need to identify the number of the main orientation of the families. So we can group the families, the pseudoplanar surfaces on the families, then transform the pseudoplanar surfaces in cluster, round by points, and finally combine different clusters in convex hull to simulate individual joints. This, for example, this is an example. The slope has 3 families, but only show results in the familiar subvertical and perpendicular to the slope. And here you can see the convex hull, and for example, yes. Imagine this part that is differentiated in the road, but with our methodology, we can take only a convex hull and a joint. So we can measure better the persistence of the joint. From the convex hull, we obtain the traces on the middle slope of the plane, and from the traces, we can compute also again automatically persistent and spacing histogram, and for example, the spatial distribution of the RQD. Okay, the third project, what I'm going to talk is the same thing, but instead the previous applied to rock slope, and now applied to tunnels. It's a work by Pan from Tongji University, and my explanation will be very brief because I only want to show that you can do the same approach and slope in tunneling. So something similar, they create the model of the tunnel face, although in this case they use both structure from motion and laser. Carry on a coplanary test to identify the points that are in the same plane. group something similar, group the individual planner in groups depending on the orientation. And from this, they obtain the discrete fracture network. And from the discrete fracture network, the traces, but on the tunnel face. The methodology is similar, although mathematically different. Okay, if you go with this method to the tunnel construction, you can work with continuous surveys of the tunnel face to creating different models. Then carry on the previous analysis to each phase to obtain the traces in each one of the model, in each of the phases. And then you can incorporate all this information into a model of the complete tunnel and create a discrete fracture network for this tunnel. Incorporate this information in a digital model to store data, to carry on analysis or whatever you need. So something similar to previous, but instead to rock slope, apply to tunnels. And the fourth case project is a particular project of characterizing an underground space using drones. The project was led by Eugenio Sani and Ruben Galindo, that they are professors at this school. Also a group of professors of this school participate from geology and geotechnic. But I want to highlight in this presentation my colleagues Antonio, Jesus, y Angela from the graphical expression teaching unit, who took part of the modeling part. Okay, so between 18 and 18 December 18, 19 last year, a sinkhole appears next to a 3-story building in a residential area in Aranjuez, south of Madrid. It was a sinkhole in a karst area with evaporized rock. And I'm going to show how we capture the information with drones. The first, I'm going to show 2 videos. The first is only a close-up of the area of study. So this and this. And the second video, the drone was flown into the cavity, so they can take photos of the cavity to create the model. It's only a 50-second video. Okay. They use Bentley software, iTwin or eTwin, to create the model. It's a point cloud model, although at the beginning it's a point cloud model. It's possible to transform to a mesh model, so it's easier to interact with or to extract information. The last video is only a screenshot of the eTwin. I thought the possibility to open the program, but I think it's safer this. So this is the point cloud model. And this is the mesh model. From using the model, you can generate a topographic model with the contour lines, and also to carry on classification analysis. For example, all this very, very simple. It's only to show that it's possible. It's a classification analysis to differentiate between buildings and ground. For example, this part of the sinkhole, the lower part in red, is because a company has started the filling of the sinkhole, the cavity. And I told previously, using the mesh model, you can interact easily with the model. You can create a cross-section of the model, or for example, to calculate volumes. For example, in In December, the depth of the hole was around 16 meters with approximately volume of 2,500 cubic meters. And 1 month later, comparing models, the depth increased to 22 meters and the volume increased to 3,700 cubic meters. And it's also it's possible with this model to add information, for example, a cadastral plane. Although with the model, you can see that the cavity developed under the buildings. Here is easier, and also you can see the problematic of the situation. And now to finish, this is the solution to fill in the cavity with cement mortar. And it's time. And now that's all for me. Thank you for your attention.
So thank you. If maybe at the end of this session, there will be time for questions or during the network coffee. Thank you, Salvador, for these interesting insights into the ground characterization. Yes, and I will introduce the next speaker, also from this school. He is PhD candidate, and we now switch from the construction and ground characterization to the operation and management of existing tunnels. In Madrid, we have one of the longest urban tunnel system, that is M30, 43 kilometers long or 42, something like that, kilometers long tunnel. So the operational management is challenging. Yes, and this presentation will be in Spanish. Okay, thank you.
Buenos días a todos. Muchas gracias por invitarme a presentar los avances que estamos desarrollando dentro de la cátedra Madrid Calle 30. Que, bueno, yo acabo de terminar una tesis doctoral, como acaban de presentar, y, bueno, vengo a presentaros los avances más relevantes en cuanto a la construcción de un gemelo digital de Madrid Calle 30, que tiene una gran parte, como veremos posteriormente, de tramos soterrados. Y, bueno, la presentación me centraré principalmente en la construcción de ese modelo BIM, que será la base para el desarrollo de un gemelo digital de la carretera. Como decía, esta presentación va a ser un extracto de la tesis doctoral que se llama Gestión Inteligente de Activos, basado en BIM y GIS para la conservación y explotación de infraestructuras, aplicación a Madrid Calle 30. Y bueno, ha sido posible y financiada gracias a la cátedra que pertenece a esta universidad, a la Escuela de Caminos, que se llama Cátedra Madrid Calle 30 UPM. La presentación girará, como decía, en la construcción de ese gemelo digital, o a partir de un modelo digital, que este modelo digital ejecutado en aplicaciones BIM, que, bueno, me voy a anticipar un poco, como la gestión en Calle 30 se realiza a través de herramientas GIS, pues ese modelo BIM lo vamos a desarrollar a través de un proceso de integración BIM-GIS a partir de datos espaciales en GIS. Pero antes de nada me gustaría comentar algunos ítems que definen el porqué de esta investigación, ¿vale? Y es que al final todos los sectores están dentro de la transformación digital. El sector AECO no es ajeno a estos cambios y, aunque va a su ritmo, las va implementando poco a poco. Además, tenemos un parque de infraestructuras cada vez más envejecido, que va cumpliendo años, especialmente aquí en Europa, y la sociedad nos está demandando altos estándares tanto de calidad como de servicio, lo que nos repercute en unos altos costes de operación. Lo que nos va a permitir esta digitalización en la gestión de una infraestructura existente es tener un mayor conocimiento sobre el estado de nuestra infraestructura. Para ello va a haber diferentes tecnologías habilitadoras. Una podría ser la sensorización por medio de dispositivos IoT, quizás sea de las más conocidas. Pero si hablamos de la tecnología habilitadora en el sector AECO, tenemos que hablar de BIM. que muchas veces se limita a la edificación, fases de operación y mantenimiento, a las fases de diseño y construcción, pero que abarca el ciclo de vida de cualquier infraestructura, incluida la fase de operación y mantenimiento. Muchas infraestructuras del transporte se gestionan mediante herramientas GIS, por eso cada vez más se habla de lo que se conoce como integración BIM GIS. Calle 30 es un ejemplo de este modelo, pero si queremos unir todos los datos que tenemos dentro de la gestión de esta infraestructura, tenemos que hablar de estandarización, porque al final vamos a tener diferentes infraestructuras que van a influir dentro de nuestra infraestructura propia, por lo tanto tenemos que ser capaces de comunicarnos entre todas ellas. Lo que nos lleva a cerrar el círculo, que no deja de ser que la digitalización se va a centrar en la gestión del dato, lo que nos llevaría al desarrollo de ese gemelo digital. Bueno, algunos datos sobre calle 30, para los que sois de aquí la conoceréis un poco más, es el primer anillo distribuidor de alta capacidad aquí en la ciudad de Madrid, pertenece al ayuntamiento, a partir del 1 de enero será 100% pública. Algunos datos, pues mueve cerca de 488 millones de usuarios al año, lo que se traduce en más o menos 1 millón de vehículos al día, distribuidos a lo largo de sus diferentes arcos. Son 32 kilómetros de anillo, de longitud, que, bueno, sumando todas las calzadas, serían cerca de 200, algo más de 200 kilómetros, que con las diferentes ampliaciones que se están desarrollando actualmente, como pueda ser la prolongación por la salida de la 5 o la cubrición del Paseo de la Castellana, pues sigue aumentando, ¿vale? Otros datos podrían ser que tiene cerca de 100 estructuras de puentes y pasarelas, pero si nos metemos en el tema de los túneles, de esos 207 kilómetros, actualmente son 48 kilómetros de túneles. Algunas instalaciones que pueda contener estos túneles pues son 900 extractores, más de 200 salidas de emergencia, 100.000 metros lineales de tuberías de protección contra incendios, otros tantos de fibra óptica, etc. ¿Qué quiero decir? Que tenemos un gran volumen de datos que gestionar. Entonces, metiéndome ya en la construcción de este modelo digital, como decía, reitero una vez más, lo hemos hecho con metodología BIM. Este es un render del modelo, de uno de los modelos finales de dentro del túnel. Pero para construir este modelo, antes de nada, lo más importante es recopilar toda la información, organizarla y que nos sirva a tener datos para una futura gestión, porque si no, al final el modelo va a ser una caja vacía. Posteriormente será construir ese modelo en 3 dimensiones y, por último, para garantizar que el correcto funcionamiento de ese gemelo digital, tenemos que garantizar el acceso y visualización tanto del modelo en sí como sobre todo de toda la información que podamos tener asociada. Todos los datos han sido facilitados de la empresa gestora Madrid Calle 30 y la empresa que hasta el 1 de enero del 2026 se encarga de la explotación de la carretera, que es Mesa, es un socio privado, nos han cedido todos los datos. La mayoría de estos datos van a ser datos GIS, ¿vale? Datos en 2 dimensiones, con principalmente inventariado y algunas salidas de emergencia, muchas secciones y plantas en CAD, algunas de estas van a estar en PDF, y también disponíamos de nubes de puntos. Estas nubes de puntos, me voy a parar un poquito en ellas, nos van a permitir dar ese salto de calidad frente a la generación de un modelo BIM a partir de los datos GIS, ¿vale? Lo malo de estas nubes de puntos es que al final son muy paciencia y recursos para poder operar con ellas. Al final, la suma total de todas las nubes de puntos del interior de los túneles suma cerca de 12 terabytes. Y luego tenemos pues, un montón de documentación técnica asociada de todo tipo, presupuestos, informes técnicos, normativa, etc. Bien, como decía, antes de nada, lo más importante va a ser poder organizar toda la información para poder transformarla en información útil. Para ello nos hemos adaptado a la base de datos actual de calle 30, pero necesitamos poder relacionarnos con los modelos geométricos, por lo tanto es muy importante coger todas estas claves de identificación que identifican de manera única cada una de las entidades de nuestros modelos. Para ello hemos adoptado como clave primaria la actual identificación que se utiliza en la gestión de calle 30, que es, lo llaman ellos código Rothschild, no deja de ser una referencia lineal en función del PK. Y en cuanto a la construcción de esta base de datos, con respecto al sistema actual en GIS, simplemente decir que al pasar a un modelo en BIM, pues vamos a necesitar escalar esta base de datos. Tanto verticalmente, porque vamos a tener mayor nivel de definición de algunos de los elementos que componen el equipamiento vial de la carretera, como horizontalmente, porque tenemos que se adopta la jerarquía de la estructura jerárquica de los modelos BIM. Me refiero a categoría, familia, tipo, elemento. Llegando a una relación, a un esquema de una base relacional similar a este. Vale, para la construcción de este modelo digital se han utilizado todas estas aplicaciones. Simplemente decir que hay un gran proceso previo sobre el tratamiento de la información previa, mayoritariamente va a ser la extracción de coordenadas, y con un proceso semiautomático en una conocida aplicación de modelado arquitectónico, pues vamos generando los diferentes modelos, tanto de los túneles como en superficie. Todo este proceso y la posterior publicación en escenas en GIS en 3 dimensiones sería lo que conocemos como BIM GIS, integración BIM GIS. Como decía, el proceso de generación de estos modelos lo hemos realizado de manera automatizada, a partir de coordenadas cartesianas, utilizando programación por objetos, que bueno, cogemos los archivos de cada una de las familias que componen nuestra carretera y vamos colocándolos de manera automatizada. En cuanto a las nubes de puntos, nos han permitido dar un salto cualitativo en estos modelos as-built de nuestra carretera, permitiéndonos ajustar algunos datos muy relevantes. Principalmente en túneles nos va a permitir conocer la posición exacta de alguna de las familias, o por ejemplo algún dato tan relevante como pueda ser la profundidad de los túneles, que hasta ahora era un dato no del todo conocido. Y en superficie también el ayuntamiento realizó una serie de vuelos fotogramétricos. Hemos cogido las nubes de puntos derivadas de esos vuelos y hemos podido generar en superficie pues, un modelo mucho más realista, permitiéndonos obtener perfiles longitudinales y transversales con mayor detalle. Todos estos modelos se han generado con un nivel de desarrollo, los 300, en esa aplicación de BIM, generando este tipo de modelos BIM. Este es solamente del tramo de la avenida de Portugal, es la salida por la 5. Hay más tramos desarrollados en BIM, lo que pasa es que son en superficie. Estos modelos los vamos generando en esta aplicación y los exportamos al estándar BIM, el IFC, y los volcamos en una aplicación GIS en 3 dimensiones que nos va a permitir dar mucho más rendimiento y poder vincular toda la información que tenemos en nuestra base de datos, asociándola a través de esas claves que he comentado anteriormente, que nos permiten relacionar toda la información, porque además al mantener toda esta información aislada en nuestra base de datos nos va a permitir tenerla actualizada y no tener que ir actualizando todos los modelos una y otra. Y por último, me gustaría hacer un pequeño comentario sobre si merece la pena invertir en este tipo de tecnología. Desde la investigación hemos tratado de valorarlo por medio de 2 métodos. Primero, mediante un análisis multicriterio bajo criterios de sostenibilidad, que se centra en diferentes escenarios de conservación, que nos sale que la gestión actual ha mantenido la carretera en unos estándares de calidad y servicio muy elevados, por lo que seguir mejorando y manteniendo esta carretera a la vanguardia en la gestión pasaría por seguir adoptando diferentes tecnologías y medidas enfocadas hacia la digitalización. Y por último, mediante un análisis económico por un ROI. ¿Vale? En este ROI hemos tenido en cuenta algunos costes típicos, como puedan ser los costes en BIM, costes en formación del personal y personal dedicado al proyecto BIM, pero el principal coste va a ser la construcción de nuestro modelo BIM. Diferentes autores proponen estos rangos porcentuales sobre los posibles beneficios que pueda adoptar la metodología BIM dentro de los proyectos de construcción, ¿vale? La mayoría se van a centrar en beneficios a lo largo de las fases de diseño y construcción, pero si nos centramos en la fase de operación y mantenimiento, tenemos unos rangos porcentuales que estarían cerca del 20-40%. A nosotros nos ha salido unos datos un poco más contenidos, pero siguen siendo resultados positivos. Y esto sería todo. Muchas gracias.
Thank you very much, Jorge, for presenting this amazing model of an amazing infrastructure. Now we go with two engineering firms. The first presentation is from Jorge Jerez from Geoconsul. Geoconsul is an engineering firm specialized in ground engineering and underground engineering. And I think he is here. Sorry. He will talk about the entire life cycle management of a tunnel. So thank you. The floor is yours.
Es esta. Es así. Cuidado va a tener. Pues no explica. Bueno, por si acaso. Hello everyone. Thank you for inviting us. Well, in this session, what we're gonna present is Maintune, an integrated tunnel lifecycle management using digital twin technology. So this is a platform that we have been developing in Geoconsul since the last years. And today we're just focusing on the first one of the main objectives, that is to identify structural anomalies and deterioration using 3D laser scanning and comparative analysis with machine learning. This platform that we are continually developing, the next objective will be to assess all the life cycle of a tunnel, and it will include real-time monitoring, predictive maintenance, cost optimization at the end, and finally, fully digital management of the infrastructure. So we have seen the previous presentation, starting by the geotechnics. Now we move on to the current state of the tunnel. So we're going to do, we normally do a structural inspections. We are going to do this by a mechanized inspection of all the infrastructure. That can be railway, road, or derelict tunnels, but it could be also some shafts. What we do is the recording of the structural pathologies, and this is supported by dynamic or static laser scanning. From we obtain high-resolution images of the tunnel line, if it has it. We can do an inspection of blank tunnels that is very useful in the long tunnels that have a limited time frames, and we can do the inspection based on the office. This reduces the inspection and the on-site costs. And we also do an assessment on the infrastructure condition indices that we will see afterwards. So we can divide an inspection in three main phases. That it will be the first part, the digital twin. We will move on and we explain how we do with the laser scanning and how we obtain the photographs, just as we see with the previous presentation of the colleague. And then we do a proper tunnel inspection, geotechnical and structural inspection. And finally, in the office, we process all this data collected and we assess the current state of the infrastructure. So the digital twin, okay, how we make it? We have seen many examples. What we do is do an installation of the laser scanner on a vehicle that is adapted to the tunnel platform. It can be in a rail vehicle, or it can be in a conventional car or in a pickup. And we obtain a digital twin that we see on the bottom image with a point cloud. We also obtain a 360 photography along the entire tunnel, and we can create a tunnel viewer that is very useful to check and review in the office. Point clouds, no, that's the main point. One is the beginning, no. So the point cloud is captured in both relative and absolute coordinates, and in each point it has coordinates X, Y, Z. So and pixel data, no? So we can do a clearance study or measure in the point cloud. The resolution we are obtaining, it's 9,000 points every 2 millimeters along the full tunnel length. And we obtain a high resolution 2D plan view of an unwrapped or unrolled representation of the point cloud. So where we can plot or map all the pathologies in the office. In the bottom image, that's the albedo image, the point cloud on the top right, and on the bottom right, the 360 photography. This is a railway tunnel, and it's quite long, 2 tubes of 8 kilometers in Galicia. And some of the photos are from this tunnel. Also, to the albedo image, we can plot over it a thermography image that we obtained with thermographic cameras. No? So we can detect the moisture through the temperature variations, and we can also confirm or guess where the water is coming into the tunnel and check the assumption we suppose at the beginning or during the whole inspection. The second phase, it's a proper tunnel inspection that it's carried out by specialist engineers. And if it's possible, well, we have to have the digital twin. So we can focus on the main spots of the tunnel that we have previously selected, and it's easy and we don't lose time in things that doesn't matter. No? So that's very useful also in railway tunnels that you have very amount of time to check. We do a structural report. We assess the condition of the infrastructure. We evaluate the severity of the existing pathologies, and we also can approach to define some potential repairs and also the urgency of this implementation. That's what normally when there is an urgency, that's the very important thing. And also we can complement it with a proposal of geotechnical investigation to confirm or to evaluate whatever we are thinking. So then during inspection, we have an idea, but we are checking all the things. No? We do a preliminary recording of the pathologies that will be supported and completed in the office-based inspection. We do instructional inspection of the lining with visual inspection, and we can also do some tests. We do also a geotechnical analysis to determine the causes of the observed pathologies. That's normally the geotechnics and the geology is always behind, or in most parts, the most difficult part to define, to confirm the origin, no? And then you can make the measures to repair them. And we identify some critical areas and the risk that the tunnel or some part of the tunnel may collapse. So what we have done in Consult is like an index that we can. We give some points, a score along the tunnel, and based on a semaphoric color scale, we can define which part of the tunnel needs more attention. And also that's very useful when the budget of the client is limited and you have to focus in the worst part of the tunnel. ADIF is also collecting by many inspections a lot of database of these inspections, and they also have some index in order to catalogate or select to identify the state of the actives. We can complement the inspection with boreholes, with core sampling, so we can determine the thickness on the condition of the materials, whether the lining is concrete, masonry blocks, bricks. We can also identify some voids On the extra doors, we can assess the ground conditions in the backfill. We can do some tests in the steel reinforcement. And if it has water, we can also have analyze the water aggressiveness and evaluate the effect on the tunnels. And we normally do also, if we extract a core, uniaxial compressive strength in order to obtain values, and we can check in the office the calculations. And also see how is the, for example, in the left bottom, there is the segmental lining, the concrete, and then the gap fill that it's absolutely deteriorated. Okay. Finally, we get to the office. No, we get to the office with all this information, and we do a representation of the pathologies in the albedo image. In this picture, you see a series of numbers. These are segments of 1 meter, more or less, that we divide the tunnel, we identify by number, and from this, we can later do some extract some statistical data and correlate with the information we have seen. What we do is an automatic localization and representation of the pathologies by pixel comparison, and we implement automatic detection tools. Here, there's a small video, a sample video of how we do this. No, so the first part is we use ArcGIS Pro, and there is a first automatic pixel classification in the raster image that it's an unsupervised inspection, and it selects automatically some categories that you can define by the user. And afterwards, what you do is you create from a catalog the pathologies you want to assign. In this case, this is the tunnel. The main pathology was associated to water ingress. So then what we do is we manually now assign to the initial automatic filtering data using expert judgment. So that's, we cannot give everything to technology, but we have to see and to check and also to train the machine to say, okay, this that you have detected is not, for example, it's no water, it's a stain, whatever. No, that's the main point, and that's where the know-how of the companies and the expert judgment is still very, very valuable. It depends on the tunnel, no? So we can, it's not the same arrival road or a shaft or even a hydraulic tunnel. So here's an example of the pathologies that we normally see on the railway tunnels. It can be linked to water ingress, to environmental or lack of maintenance of the tunnel, some structural and material pathologies. There's a lot of variety, and it depends on every tunnel and also the background of the tunnel. We cannot forget about the functionality, the drainage. Sometimes there is an obstruction of the drainage, and also the track deformation. With the point cloud, it has coordinates, so we can measure, we can do a clearance study, and also we can check the track. No? And that's very useful because you have a doing model. With the sectors we saw in the albedo image previously, we obtained some statistical data. So we represent in GIS, and we use Python scripts to plot in Excel a graphical representation of the pathologies. It depends what we want to plot. No? I mean, you have a lot of data and you analyze. Sometimes you don't know what's happening, but sometimes you correlate all the information. For example, in the middle graph, we see that this was a segmental lining. The segmental rings were incorrectly installed, and that was because of the TV learning curve. So you can correlate, okay, this what happened? No, it's like an investigation. That's what you do based on the information, and with the more information you have, the better the approach. And finally, once you have done all this, you can propose a tunnel rehabilitation. You can do a structural repair of the lining, where you can repaint the ground, the walls. You can also define a waterproofing and system or a drainage improvement. the platform repair, or also the portals that in many cases, it has a lot of pathologies. There is also another action that we do is the tunnel section enlargement for new functional requirements. It's mainly in railway tunnels, and we need due to a new functionality to increase the section by lowering the platform and rehabilitating the existing lining. That's one option, the cheapest one, but maybe not the best, it depends. And the second one, a more powerful action, it's a radial section increase involving excavation for enlargement and the installation of a new support. All this process, I have just disposed all the information we create, a pound cloud, tunnel video image, the mapping of the pathologies, the tunnel view in 360, all the inspections, and basically all the documents we generate. You can find them in a web platform that the client can consult it, also the partners involved and everyone involved. And this is very useful if you do it every year or every 5 years. And finally, this is a sample video of this platform, the web platform. You have located your tunnels, you select where it is. You get to the tunnel and you can download all the information we have. You can click on the albedo image and you can see the unwrap, unroll albedo image, and with all the mapping of the pathologies. And so you can put the thermography, and this is the tunnel viewer. You click and you have the 360 photographies. You can move along, and as you see, it has like a lot of resolution. Is better than Street View. So you can check it if you do it every year. But you can check it every year. So this is the end of the presentation. Thank you very much. And yeah.
Thank you very much, Jorge, for this nice presentation. You have enriched my open speech with the part of the pathologies detection, because I was totally thinking on road tunnels, but also, for example, in hydraulic tunnels, there are some situations very common in which nobody wants to enter in the tunnel to see what's going on. And I think that the robots can be convincing more easily. So next speaker, it's my pleasure from AYESA. AYESA is a very important engineering firm. And we are lucky because we have the head of ground engineering and tunneling. He brings a very long experience working worldwide in tunnels and underground construction. And today, emphasizing the European dimension, I think he's going to talk about a subway line in Portugal, in Porto. So thank you very much. The first.
So good morning, everyone. Thank you for inviting us to present today. I'm going to be talking about going back a little bit to the design perspective of a digital twin. So we're going to prepare a digital twin that then can be used for the other stakeholders and take it forward. This was implemented or is being implemented in the Porto Metro 3.0, as we're going to see in a second. I think change it. Okay. And we will cover the main aspects of this methodology. We're gonna be using a lot of the softwares, the powerful softwares from Bentley, and we are actively collaborating with them for implementing these. So the use of Leapfrog, for instance, the OpenTunnel and Plaxis. But we also have some in-house apps that we developed for doing this. So starting by introducing the Porto Metro expansion. This is the Porto Metro 3.0 expansion. So this is the plan for 2030 of the Porto Metro. It will expand the current network by 55%. So they currently have about 70 kilometers. And we're gonna add 40 kilometers to that. It also includes 38 new stations. You can see that this is actually not a single line, but there are 4 new metro lines planned. A bit like not at the center, they are more like radial going to the surrounding outskirts of the city. For this presentation, we're gonna focus on one of the lines to show you the methodology that we developed, but the same methodology is being implemented for the other ones. Also these 4 lines in combination, they represent an investment of 1 billion euros. Starting then by introducing the line that we chose to show you the methodology this is the line at the south side of Porto. This is the line Dragão Souto. Probably you know the name Dragão because it's the football club of Porto. So it's one of the most famous football clubs of Portugal. And you see actually on the left side, the stadium where it starts the line. We then have a tunnel to go underneath existing rail. This is about less than 1 kilometer tunnel. So the line in total is about 7 kilometers, in which 3 kilometers are tunnels. It's not the total line is not in underground. You will see like there are 3 tunnels. So the second tunnel is the tunnel connecting from Lagarteiro to Lagoa, and the third tunnel is the tunnel connecting Lagoa to Valbon. So this is the new workflow. It's quite complete. Basically, we take advantage of the existing information, we process it, making it digital, or either we supervise the ground investigation, and we also create a digital twin of that, basically, or a digital database for that. We then use 2 internal developed apps that we have to create the digital database. We share that information, or we send that information to Leapfrog Works to create a geological model, and then it's shared with OpenTunnel and then Plaxis. You will see it now being used. That's at the level of design. We also have an internal application that allows us, once we have the model in Leapfrog, to process it and to send it to Civil 3D. And from that, we can extract the geological sections from the project automatically, and so on. The reason for this is like, in reality, you are able to use Leapfrog to create geological units, but they are not the ones that we want to see like for deliverables, because they have to be then processed in terms of CAD. That's why we have this part of sending it to Civil 3D and then being able to doing the templates of the drawings and all the things we have to do for the deliverables. Having it in the 3D, then we send it to the sections, as I was saying. We are able to do the bill of quantities directly from that. So everything that we have in Leapfrog, we are able to measure. So if you cross any unit, you are able to measure the amount of unit you have in that. And we also create the project drawings. So I think it was good that I think Salvador was mentioned that everything starts in the field. So either we get the information from the previous campaigns, or we are doing the supervision ourselves. We have tablets to get that. So the application obviously works in our tablets. We get the information. It can be like boreholes, for instance, as you see here. The boreholes then are listed for the project, or you can also have other types of information from the field. So it can be like, for instance, the characterization of rock mass. And then we are also implementing now the part of the lab. You get the sheet, for instance, for the part of the inspection of the embankment slopes. You are able to see that in terms of your project, how this information is located in the city, in this case, of Porto. And then we are also able to export it to different formats, either to create reports automatically from the campaign, to send it to Excel, in which you are able to edit it, to send to Alert, to send to Leapfrog, and others. Now we can see a model of Leapfrog being used for the line of Dragão Soto. Basically, you have the geological map, you have the topography in the model. You can see the alignment of the, not just the tunnel, this is the entire line, the 7 kilometers of, you see in different colors, the different geological units. So in red, you see the granites, in green, you see the metamorphic rocks of Porto. As these are very weathered materials, you see a lot of units associated to it, so different colors, but the main two formations are the granites and the metamorphic rocks. We are also able to see the buildings, not just because, you know, it's nice to have them here, is mainly because in a tunnel project, it's also important to see the assets you have at the surface and how many basements they have, because the basements are going to be potentially an obstruction for the tunnel, and you're able to see if there is any clash by having it here. We also see a lot of the boreholes that were used, the part of the seating profiles, and we end in this part by seeing the tunnel. So the tunnel is actually there, and we're going to see it now in a bit. So this is the part in which now from the Leapfrog model, we are able to send it to OpenTunnel. So OpenTunnel is a dedicated software to create a tunnel using BIM methodology. So here you can see the geological model that was created in Leapfrog. It's being imported. We also have the database of the units. So for instance, if you are using constitutive model as hardening soil, is being saved here. We are now associating the different stretch of the tunnels to different sections that we have. So rock, one of the sections are in rock, other ones are in soils. It's just picking the, you see the typical sections for the soil in this case. So this is actually quite fast, not just not hours, but a few minutes. So the tunnel is generated with 4 different typical sections for the entire stretch. You can see it now with the geological units. And now in this final part of the video, basically, we're gonna also add, since some of the part is the rock tunnel, we're gonna have to add also rock bolts to the model. So we're gonna select the sections and the type of rock bolts we're gonna use for that. So you see the selected part now says rock bolts. And the final part actually is as for polling. So we are also able to do the for polling or face nailing, whatever you want to do. So you'll see the last stretch of the tunnel now are going to have for polling being implemented as well. So you see these are actually a bit inclined. There is a for polling there. So the next thing is like we also have some emergency shafts. For the emergency shafts, we decided we have 1 per tunnel. We decided to use a Revit because since it's like a building kind of structure and we want to model the stairs and everything inside, we use Revit for that. But we are also able to see the connection. Basically, you can export from the Revit model to OpenTunnel, and you are able to see the shaft there and do the intersection. We also see the galleries connecting the shafts and the running tunnels, and they also have rock bolts or wherever it's necessary. So for the shaft 1 or the shaft 2, you see actually the shaft 1 has rock bolts, but the shaft 2 only has for polling, and then shaft 3 also for polling. Now, we are going a step further, that is how we actually now do the calculation for the design is, since you already have the tunnel model and the geology into the same model in OpenTunnel, we are able to define the sections that we want to analyze. So in this case, we are assessing a few sections. We just select, export whatever sections we want. We give it like in terms of kilometers or wherever they are located. The next thing, we open Plaxis. Obviously, since these three softwares, Leapfrog, OpenTunnel, and Plaxis are from Bentley, they work quite smoothly between themselves. And now we have a Python script that basically will call these sections that we already export from OpenTunnel with geological units and already has the database of the units. We ask it to create as a model, and you will see the model is created like quite fast. So what is different in this is that typically we idealize the sections when we are designing tunnels and we just do the worst case scenario. In this case, we are able to do sections every meter, every 2 meters, because this is quite fast process of doing it. Once we have the sections, we just create at the end the construction phase. So we are able to do this kind of sections. So they can be quite realistic with intersections. We are still able to do the worst case scenarios if you want, so the horizontal sections. But this is the most, I think now you will see the different parts of the phase being implemented. So you see the model. This is necessary for such a heterogeneous ground conditions such as the ones we are encountering in Porto. And then you can see the part of different phase of excavation. We model both the excavation and also the permanent lining. So the permanent lining is also modeled in Plaxis, and we use a strategy there to do a wish in place phase in which we use the model directly to design the secondary lining as well, not just the primary lining. So you see the different parts of the model now. The phase, going through the phase, you have the primary lining, and then you have at the end the secondary lining, in which we do the short term, and we also do the long term with some conservative approach for the design. This is pretty much it. Regarding then the damage assessment, this is also very important when we are working in an urban environment because we have lots of buildings, lots of utilities at the surface. So the same buildings that we were seeing that were used for Leapfrog, they are then sent to XDISP, and we can see then the methodology being implemented for different parts. So for instance, you have several buildings in which we are assessing. It's more, maybe more visual in the case of the tunnel number 3 because we have more buildings. So this is actually what corresponds to already a phase 2 damage assessment. So typically damage assessment phase 1 is just a greenfield settlements contour, in which one in this phase 2, we already account for the stiffness of the buildings. And then in phase 3, we will be able to select the buildings that we see with a potential risk here. And we send it, for instance, for Plaxis, or we do a special assessment of that building. And from these, we are able to export directly to create the project drawings, the deliverables in terms of damage assessment and in terms of monitoring. So the benefits we are seeing on this new method that we are kind of like still working on it and we are improving it. We started roughly 1 year ago, is that obviously we are creating a digital twin of our model that then can be sent to, for instance, for construction, and then you will update it as you create this build of your project. Is more sustainable because we need less resource, so you don't need so much paper, for instance, in the office. It also allows us to assess many more scenarios that before we were not able to assess. So before we were only, we were limited a little bit by the amount of models we were created. By doing this method, the number of models we can create is almost limitless. It reduces obviously the problems with the different disciplines because then we share it in the FC and we do a clash detection with the other disciplines. Obviously, enhanced communication among the project team. This brings better quality for the design. Also with the client, because we are able to show them the particular problems, particular clash that we need to solve. And also stakeholders and other parties, we are able to show this model and see that actually will not impact the building, for instance, and for instance, a person that is also technical is able to see it in a more visual way. At the end, it brings a more informed decision-making in terms of the project, because we are seeing it in 3D, not only in 3D, in 4D, because we see it in terms of the construction sequence that I was showing. And at the end, what we expect to have, and what we are seeing is like, we get better quality and added value for our projects and our clients. And is a more integrated and digital approach to the project. So this is pretty much everything. Thank you so much.
Thank you very much, Claudio, for this insightful presentation. I think from here from academia, it's very easy sometimes to launch ideas like let's cross the Strait of Gibraltar with AI. But then it is important from the companies that you explain how you integrate these processes and the tools that you use, because you have to design or build a tunnel and eventually to make money. So I think it's very good. The last speaker of this session in the morning is coming again from Comunidad de Madrid, from the Dirección General de Infraestructuras. Is Álvaro Ruiz López. He was already introduced by the General Director, and he's going to talk about the approach of this administration on how to use BIM. Thank you very much. The floor is yours.
Hola. Buenos días, mi nombre es Salvador Ruiz, soy jefe de unidad de la Dirección General de Infraestructuras del Transporte Colectivo, ¿vale? Entonces, lo que vamos a ver hoy, bueno, vamos a explicar, vamos a hablar de la metodología BIM en la Dirección General, ¿vale? Y vamos principalmente a tratar estos 4 puntos. Bueno, por un lado, ¿qué es la Dirección General? ¿Cuál es el trabajo que desarrolla? ¿Cuáles son sus competencias y cómo opera? ¿Vale? Por otro lado, vamos a ver cómo hemos implementado, bueno, todavía estamos implementando la metodología BIM en la Dirección General. Luego vamos a tratar muy someramente los proyectos y obras y los requerimientos BIM en nuestros pliegos, ¿vale? Y finalmente vamos muy brevemente a hacer un apunte sobre gemelo digital y BIM, que ya os ha adelantado Miguel en la presentación de las jornadas. Bueno, pues la Dirección General de Infraestructuras del Transporte Colectivo, ¿vale? Pertenece a la Consejería de Vivienda, Transporte e Infraestructuras de la Comunidad de Madrid. La estructura, bueno, está formada por tres unidades administrativas con nivel de subdirección general, ¿vale? Que es la de proyectos y construcción, concesiones, patrimonio y conservación, seguimiento, análisis y estudios. Nosotros vamos a ver con más detalle lo que hacemos en la subdirección general de proyectos y construcción. Bueno, la Dirección General tiene las competencias que se recogen en el artículo 47 de la Ley del Gobierno y Administración de la Comunidad de Madrid, ¿vale? Dentro de esas competencias aplican a lo que entendemos como infraestructuras de transporte colectivo, que son las que enumero ahí, las líneas ferroviarias, que la Comunidad de Madrid no tiene ninguna, el metro pesado, el metro ligero, los sistemas de plataforma reservada, los intercambiadores de transporte y las estaciones, así como sus elementos e instalaciones. ¿De acuerdo? La Dirección General, bueno, tiene muchísimas competencias. La más importante, ¿vale? Es la proyección y ejecución de las infraestructuras de transporte colectivo, independientemente de las competencias que tengan asignadas el Consorcio Regional de Transportes de Madrid y otro tipo de organismos directivos. ¿De acuerdo? Dentro de en la Comunidad de Madrid, ¿no? Existen 3 figuras fundamentales. ¿De acuerdo? Está el consorcio, que es quien se ocupa de la planificación de las infraestructuras. Por otro lado, estamos nosotros, la Dirección General de Infraestructuras de Transporte Colectivo, que proyectamos y construimos, ¿vale? Y finalmente está Metro, que es el que explota y realiza la conservación ordinaria de la red de metro pesado y metro ligero, ¿vale? Vamos a ver ahora cómo hemos implantado la metodología BIM en la Dirección General, ¿vale? Y el esfuerzo que estamos haciendo, porque todavía no hemos terminado. Miguel en la introducción ya os lo ha comentado. El objetivo que tenemos es 2030 y, bueno, lo primero que tenemos que tener claro que es BIM, ¿vale? Pues, bueno, de acuerdo a la norma UNE, a la ISO 19650, define BIM como el uso de una representación digital compartida de un activo construido para facilitar los procesos de diseño, construcción y operación del activo y proporcionar una base confiable para la toma de decisiones. Por otro lado, la Building Smart Spain define BIM como una metodología de trabajo colaborativa para la creación y gestión de un proyecto de construcción, ¿vale? Con el objetivo de centralizar la información del proyecto en un modelo de información digital creado por todos sus agentes, ¿vale? Por un lado, tenemos que tener en cuenta que ya de esa definición decimos que implica muchísimas cosas. Aparte, tenemos que tener en cuenta el marco normativo y legislativo. Entonces, dentro de este marco es la Unión Europea en el año 2014 es la que empieza a pedir a los Estados miembros que empiecen a modernizar sus normativas y a implementar y su legislación y a implementar la metodología BIM. ¿Vale? Esto se hace a través de esa directiva europea, ¿vale? Y esto tiene es recogido por la ley de contratos, ¿vale? En la legislación española, ¿de acuerdo? Y por otro lado, tenemos que el Consejo de Ministros aprueba en junio de 2023 el plan BIM en la contratación pública, ¿vale? Es un plan de incorporación de la metodología BIM en la contratación pública de la Administración General del Estado, ¿vale? Y sus organismos públicos y entidades de derecho público dependientes. Vale, entonces, ¿cómo vamos? Bueno, este plan establece un calendario, una hoja de ruta, ¿vale? Para todas sus administraciones. Ahora mismo la fecha más próxima es el 1 de octubre de 2025. Todas las administraciones que ejecuten obras con un valor estimado de contrato mayor de 5 millones, de 5 millones y medio, deberían de estar en un nivel medio en metodología BIM. Para aquellas administraciones que ejecuten obras de menos de los 5 millones y medio, pero mayor o igual que 2 millones, deben de estar en un nivel inicial. Y además nos dice los niveles, ¿vale? Y cuáles son los requisitos que deben de cumplir esa administración para considerar que está dentro de ese nivel. Se estructura en 5, desde el más básico hasta el totalmente integrado, ¿de acuerdo? ¿Cómo lo hemos hecho en la dirección general? Bueno, pues lo que hemos hecho, lo que en realidad hemos elaborado un documento, ¿vale? Que es el que desaparece ahí, bueno, que es las líneas de trabajo prioritarias y el proceso de evaluación para la incorporación de la metodología BIM en la dirección general, ¿de acuerdo? Entonces, lo que hace en este documento, definimos una serie de líneas prioritarias y analizamos 4 estados de madurez. El primero en 2022, que sería el estado inicial de madurez. El siguiente horizonte temporal que nos hemos fijado es 2023, ¿vale? Que sería un nivel de madurez a corto plazo, el de 2024, que sería un nivel a medio plazo, y el de 2030, que sería, bueno, pues obtener el total, vamos, llegar al nivel integrado que recoge el plan estatal, ¿de acuerdo? Entonces, ¿cómo lo hemos hecho? Pues a través de 4 áreas de análisis, ¿vale? Definiendo 41 indicadores. El área de análisis de estrategia tiene 3 indicadores, el de personas 8, el de procesos tiene 14 y el de tecnología 6. Todo esto nos lo hemos llevado a una matriz, ¿vale? De maduración, y lo que hemos hecho es puntuarlo en base a cómo nos encontrábamos en el de maduración inicial. Y hemos visto qué capacidades debemos de reforzar a través de nuestra estrategia, ¿vale? Y al final lo hemos concentrado todo en 3 líneas de trabajo, ¿vale? Que sería para la implementación BIM, para la digitalización de todos nuestros procesos y para la adecuación de todos los medios. Ahí aparecen los indicadores, los 41 indicadores agrupados en esas 3 líneas de actuación, ¿vale? Este es el nivel de madurez en el que nos encontrábamos inicialmente en el estado actual, ¿vale? En 2022, que estábamos en un 30,20. El nivel el tecnológico es el que más baja puntuación tiene, y a base de esfuerzo y de seguir la línea estratégica que nos habíamos marcado con la matriz de madurez e ir implementando la metodología, hemos conseguido en el primer horizonte temporal, en 2023, llegar a un 50,20. ¿De acuerdo? Bueno, aquí os resumo rápidamente para todos los indicadores en las 4 áreas que hemos definido, ¿vale? ¿Cómo estaríamos? No sé si lo veis bien, está cada uno de los estados, los cuatro horizontes, los 4 niveles de madurez representados. El objetivo es llegar al 100% en 2030. En 2024 nos hemos retrasado, deberíamos de estar cerca del 80%, pero no hemos conseguido porque actualmente, que ahora lo vamos a ver, todos los recursos de la Dirección General están trabajando en todas las obras que estamos llevando a cabo, entonces no nos ha permitido avanzar como hubiera sido deseable. ¿De acuerdo? Y dentro de esas 3 líneas que os decía, pues estas son las que, bueno, estas son todas las áreas que debemos de terminar de implementar para alcanzar por lo menos el 80% el próximo año y en 2030 el 100%, ¿vale? Entonces dice plan de acción año 2024, nos vamos a ir a 2026 probablemente o incluso algo más, ¿de acuerdo? Vamos a ver ahora los proyectos y obras y los requerimientos, los proyectos y obras que está desarrollando la Dirección General y los requerimientos BIM que requerimos en nuestros pliegos para la contratación pública de todas nuestras obras, ¿vale? Actualmente, bueno, hay 2 grandes líneas de actuación dentro de la Dirección General. Por un lado, la construcción de nuevas líneas de metro y la ampliación de las existentes, ¿vale? Y por otro, la ejecución de los intercambiadores. ¿De acuerdo? Entonces, las principales líneas de actuación que tenemos ahora mismo son la prolongación de la línea 11, de la línea 3, de la línea 5 y la nueva línea Madrid Nuevo Norte, al norte de la ciudad. ¿De acuerdo? Entonces, todas estas, aparte de las nuevas estaciones que vamos a ejecutar y los intercambiadores, que va a ser una gran actuación en el periodo comprendido entre 2019 y 2030, bueno, pues se va a ejecutar los intercambiadores, cuatro nuevos intercambiadores en la Comunidad de Madrid, ¿vale? Entonces, en lo que es la línea B, la línea 3, que está actualmente ya en servicio, lo que se ha hecho es la ampliación desde Villaverde Alto a Alcasar, ¿de acuerdo? En la línea 5, que está actualmente en ejecución, se está prolongando desde Alameda de Osuna, ¿vale?, hasta la línea 8, hasta Aeropuerto T1, T2 y T3. Luego, en un futuro se ejecutará la nueva línea Madrid Nuevo Norte. Esta dará servicio a todos los nuevos desarrollos del norte de la región, ¿vale? Concretamente vamos del norte de la capital. Por otro lado, tenemos la línea 11, que podemos decir que es el buque insignia, ¿vale?, de las obras que está llevando a cabo ahora mismo la Dirección General. Si os fijáis, bueno, el tramo comprendido entre Fortuna y Plaza Elíptica es el que se encuentra actualmente en servicio. Por otro lado, se va a ejecutar en un futuro el tramo Mar de Cristal Valdebebas, ¿de acuerdo? Por otro, se va a ejecutar el tramo de conexión entre La Fortuna y Plaza Elíptica, y actualmente se está ejecutando el tramo que os muestro aquí dentro de la línea 11, que es entre Plaza Elíptica y Conde de Casal. Cuenta con 5 estaciones, 2 de ellas nuevas, como es Comillas y Madrid Río, y el resto, Palos de la Frontera, Atocha y Conde de Casal, son estaciones de interconexión. ¿De acuerdo? Bueno, aquí he puesto algunas capturas de pantalla de los modelos BIM de las diferentes estaciones. ¿Vale? Esta sería Comillas, una sección de Comillas. Aquí vemos Madrid-Río, la sección transversal de Madrid-Río, Palos de la Frontera, que es una estación de interconexión, ¿vale? Atocha, que es otra estación de interconexión, una sección transversal, y el Conde de Casal, estación de interconexión, junto con el nuevo intercambiador de Conde de Casal, que se empezarán las obras en el próximo año. El objeto de prolongar la línea 11, que para muchos, bueno, la definen como la diagonal, porque atraviesa Madrid de manera diagonal, tiene por objeto descargar la línea 6, que es la que más utilización tiene actualmente, y descargar también el resto de líneas del desarrollo de los nuevos desarrollos urbanísticos. ¿Vale? Por otro lado, dentro de las nuevas estaciones que va a ejecutar la Dirección General, está la línea 10, la de Darío Gazapo, una nueva estación para el desarrollo de Madrid, de la Operación Campamento, perdón, y en la línea 9, la estación de Juanes Berrocales para los nuevos desarrollos que mostraba anteriormente. ¿De acuerdo? Bueno, esto lo paso porque son las reservas y demás, algunas características de la línea 10. No, es que me queda todavía, por eso no quiero entretener demasiado. Y luego, por otro lado, nos quedan los intercambiadores, ¿vale? El intercambiador de Conde de Casal está actualmente en licitación, las obras van a comenzar el próximo año. El de Legazpi se encuentra, vamos, la licitación para la redacción del proyecto saldrá el próximo año. El de Chamartín, que dará apoyo al intercambiador de Plaza de Castilla, ¿vale? Y que está asociado al desarrollo de Madrid Nuevo Norte. Y el que me he dejado, que no he dicho, que es el de Valdebebas, que se encuentra actualmente en ejecución y que vamos a ver ahora con más detalle. ¿De acuerdo? Estos son los 7 intercambiadores. Bueno, estos son los 7 más 1 intercambiadores que van a permitir, bueno, pues que los autobuses interurbanos no entren al centro de Madrid y lo colapsen todavía más, sino que a partir de ahí, cuando alguien llega a Madrid, pues ya se desplace a través de otros medios de transporte, ¿vale? Como son los autobuses urbanos o el metro o el cercanías. Perdón. Vale, aquí os he puesto unas cuantas capturas de pantalla del intercambiador de Valdebebas, del modelo, para que veáis, pero bueno, las paso rápido porque los vamos a ver con más detalle. Este es el intercambiador de Conde de Casal que ya hemos visto. Vamos a ver ahora los requerimientos BIM en nuestros pliegos, ¿vale? Tenemos que tener en cuenta, volviendo otra vez al marco normativo y legislativo, que la ley de contratos permite requerir el uso de la metodología BIM a las licitaciones públicas mediante la inclusión en el propio pliego, ¿vale? De alguna de las siguientes formas. Podemos hacerlo dentro de la exigencia de la solvencia técnica, como requisito de valoración de la oferta o como prestación adicional extraordinaria. Y además, tener en cuenta que los aspectos, bueno, que la metodología BIM está alineada con algunos de los aspectos de los criterios de adjudicación, ¿vale? Como es el criterio de calidad o la mejora en la relación coste-eficacia. ¿Vale? ¿Cómo lo hacemos nosotros en la Dirección General de Infraestructuras de Transporte Colectivo? Pues lo que hacemos es a través de nuestros pliegos, ¿vale? Todos nuestros pliegos incorporan ese documento que ven ahí, que son los requerimientos BIM en la Consejería de Transportes e Infraestructuras, cuya última actualización es de agosto de 2021. Como ha dicho Miguel en la introducción, en algunos criterios hemos sido demasiado exagerados y en otros pues nos hemos quedado ahí. Estamos dándole una vuelta, estamos corrigiendo y estamos mejorando los requisitos, ¿vale? Entonces, lo que hacemos es, por un lado, depende de si el contrato es de obra o es de servicio, requerimos la figura de un BIM manager y la figura de un BIM modeler. Este es el epígrafe 4 de los medios mínimos a disposición del contrato del pliego de las obras de lo que acabamos de ver, de la línea 11 entre Plaza Elíptica y Conde de Casal, ¿vale? Requerimos un determinado tipo de perfil y bueno, para cada uno de ellos, para el BIM manager y para el BIM modeler. Bueno, esto lo voy a pasar porque son los requisitos, todo esto está en la documentación, en el documento que les he mostrado, ¿vale? Entonces, vamos a seguir viendo lo que decía, qué es lo que pedimos nosotros en los pliegos. Bueno, pues habitualmente pedimos una memoria, ¿vale? Esta memoria tiene un máximo de 25 páginas, ¿de acuerdo? Y esto es lo que pedimos a los contratistas, que nos definan la estrategia de implantación de la metodología BIM en la redacción de proyectos, la propuesta previa de su plan de ejecución BIM y la propuesta de herramientas de hardware y de software asociadas al contrato. ¿Qué hacemos con esto? Pues esto se evalúa en la oferta correspondiente conforme a los criterios cualitativos evaluables mediante juicio de valor incluidos en el pliego de cláusulas administrativas, ¿vale? Para nosotros tiene una puntuación máxima de 6 puntos. Esto es luego el desglose que ven los contratistas en los pliegos para saber qué es lo que tienen que ofertar. Os voy a mostrar un vídeo del intercambiador para que veáis cómo hemos implantado la metodología BIM y, bueno, y cuál es el resultado. ¿De acuerdo? Bueno, pues este es el resultado de la implantación de la metodología BIM en la ejecución del intercambiador de Valdebebas. Ha sido, bueno, se puede decir que ha sido la experiencia piloto que hemos tenido, ¿vale? Junto con la ampliación de la línea 3 del Casar, con la línea 10. ¿De acuerdo? Perdón, de la línea 12 con la línea 10. Seguimos y bueno, finalmente BIM y el gemelo digital, dos herramientas poderosas. Efectivamente son dos herramientas poderosas. De hecho, son complementarias, ¿vale? La primera aporta valor en la fase de desarrollo del proyecto de infraestructura y la segunda en la fase de gestión del activo. Como ha introducido Miguel al principio en la presentación de las jornadas, la Dirección General de Infraestructuras de Transporte Colectivo no ha llegado a desarrollar todavía ningún modelo digital y probablemente no lo lleguemos a hacer porque, como os he contado al principio, dentro de nuestras competencias no está la explotación de las infraestructuras. Eso o bien los intercambiadores lo hace consorcio o la red de metro lo hace Metro de Madrid, metro pesado, metro ligero. Lo que sí que tenemos pensado es, dentro de nuestra estrategia de digitalización, es implementar la planificación de cómo debería hacerse en coordinación con estos dos organismos. Y en principio eso es todo. Muchas gracias.
So thank you very much, Salvador, for explaining the approach of the Community of Madrid. As I said, this is a leading region in the tunnel construction, so I think it's important to understand how the administration is approaching these ideas. I can witness that the physical part exists because we were lucky to visit the construction of one of these metro lines. Now, today I'm happy to see the virtual part, and maybe we must go further and talk about digital triplet or something like that, and including all the managerial, legal, and contractual aspects that are also important for these assets. So I would like to thank all the speakers. This first session has concluded. Now we have the coffee break. We are a little behind schedule, so I will ask you, if possible, to do it in 20 minutes, coming back for the second session. And I would like to clap our hands for all the speakers. Thank you. And Okay, so so thank you again. Now we are going to start the second part of the event. This session is most focused on that future that we can imagine when AI, edge computing, sensoring will disrupt the construction of tunnels and the maintenance. But we are going to present some things that we are doing already today, but that we, for sure, they will go much further. It is my pleasure to introduce the first speaker. Now we go back to academia. He's one of my colleagues. He's full professor at my department, full professor of geotechnics. He was my PhD supervisor, and he has a strong scientific background. He was PhD doctor from Berkeley University, was professor at lecturer at Imperial College, and now is full professor at this school. He's going to speak about statistical learning tools for prediction of tunnel behavior. Rafael, thank you.
Thank you, Nacho. Thank you very much for this opportunity to talk a little bit about our research on this topic. Of course, thank you to the organizers of the talk, to the Digital Twins Consortium, to the school, to Bentley for funding the talk or the session, and to other companies and funding agencies that have been funding our research in the last few years, some of which have been listed here. So the topic of my presentation is introducing a new theme, which is how to predict behavior in tunneling. You know, everybody which is involved in the tunneling business is aware that tunneling is an inherently uncertain and we can see risky business in the sense that there are possibilities for collapse, for bad behavior, or time and cost overruns. Here you have some examples. I decided to bring some examples, not from Spain, just so that people, sometimes we have the tendency to think that, you know, only bad things happen in Spain, but that's not the case. Even in countries that have like a tradition for tunneling, like Switzerland, they have had this type of examples. We can talk about phase collapse mechanisms in city environments. We can talk about, you know, squeezing problems about which we will be discussing a little bit more in depth in just a few minutes. And in essence, what this produces is that we can have huge cost and huge time overruns. But at the same time, it's a linear project. Basically, a tunnel is a very long infrastructure that we start from one end and we finish from the other end, in essence. No? Sometimes we put an intermediate starting point, but in essence, we have the opportunity to somewhat learn from the observations, from the data that we acquire as the construction proceeds. This is an example, let's say, in a traditional environment for tunneling, new Austrian tunneling method or similar. We will always have information about the tunnel phase. It's going to give us information about the geology, the rock mass, what is the quality, if there is any faults, are there any heterogeneities, etc. Right? And once the tunnel is constructed, we can also infer or measure how it's behaving. What are the convergences? What are the stresses, etc. And of course, if we go to more, let's say, technologically advanced systems of construction, for instance, TBMs, we will have even more data. I mean, this is an example from a 15-meter diameter earth pressure balance TBM machine here in Madrid. It was world record at the time. I had the fortune to work in that project for a few months. And this is the type of data you could get. You could get a lot of data on phase pressure. You could get a lot of data on the force on the jacks. You could get a lot of pressure on the injection of the grout, et cetera, et cetera. And this was, I don't know, a few years back. Nowadays, you have this data, but multiplied by maybe 10 times, 100 times, because sensors now are registering or recording data very, very often. No? And also you can correlate or you can use that data to anticipate how the tunnel is going to behave. For instance, it's very well known that depending on the quality of the construction or how carefully, for instance, you control the phase pressure, how carefully you control the grouting pressure, you are going to have very different settlements. And this is just an example from Suwansat and Einstein from tunneling in very soft ground in Bangkok. So at the end, the idea is we have data, or we are going to have data in tunneling projects. How can we use that data to be able to assess, to infer, to predict how the tunnel is going to behave in the future, right? So basically, for that, we can use what I call here statistical learning tools. You know, these people tend to incorporate that into what we call now artificial intelligence. There are many descriptions, many definitions. I'm not going to enter into details. I will just share with you what are, let's say, my very basic view on this project. There were like traditional, let's say, approaches, basically based on what I call visible models that one could understand their assumptions. One could know how they work. And basically, they were also feasible with relatively small amounts of data, right? That was the traditional approach. Basically, we could talk about unsupervised or clustering methods, or supervised or classification approaches. I will be talking about those in this talk. And then another approach, which I personally like a lot, because I think it has a lot of potential for the observational approach, but at least in geotechnical engineering, and in particular in tunnel engineering, is very important, which is the Bayesian approach. Basically, I will show you how we can use data or observation to improve our models and to make better predictions. And then we have the jungle. The current approach, honestly, I feel completely lost. It's all the very advanced or hidden models with, you know, super fast evolution, ChatGPT today coming or driving to the school. Maybe you heard in the news. It seems that Google has just produced a new algorithm or a new artificial intelligence that would have been, I think it was the second in an Olympics of mathematics. So basically, they are developing, you know, artificial intelligence to solve very, very complex problems. But they have, in my opinion, the difficulty that they need a lot of data, and they need a lot of training. And we can talk about that, maybe not in this talk, but at the end of the session in the round table, right? So my topic today, I will just present like two examples of application. One is basically a classification problem. I am going to show relatively simple tools that can be used to predict behavior. In particular, I will be interested in two specific problems in tunneling, which are excusing and rock burst. And for that, I will show how to use a linear classifier and a if-based classifier. And then, as I mentioned, I will also use in the second part Bayesian approaches, how you can use them to improve your predictions based on observations that you can make. And this can be useful in the future for site characterization, to predict future convergences, et cetera, et cetera. So let's go to the first topic, how to use classification approaches to predict squeezing first and then rock burst. Squeezing, I showed an example before, is a very challenging problem in tunneling engineering. Basically, it forces you to construct the tunnel twice. Basically, because you construct the tunnel once, you have huge convergences, you lose enough space for the use that you have predicted to the tunnel, and you have to go demolish what you have constructed and reconstruct again. So it's a very challenging problem. It can happen in weak rock, deep tunnels. It's also very complex to model or to anticipate. You know, there have been several approaches, observational approaches, numerical approaches, but numerical models are very complex. They need data, input data, which is very difficult to obtain, etc. So another approach has been to use empirical observations. We have observations, you know, we have databases from the literature in which people have studied different rock masses, and they have studied different conditions for tunneling, in particular if the tunnel was very deep, if it was or not very large, and how the tunnel behaved, if it had or if it did not have a squeezing. Basically, this column here, 0, 1, is a squeezing or not squeezing occurrence. And based on that, you can develop a quite simple mathematical model in which you have some input features, information that you know about the capacity of the tunnel, about the demand. Basically, capacity will be related to the quality of the rock mass, the amount of support, and the demand will be related to probably the depth, the in situ stresses, etc. And you have observations, which is if it had squeezing or not squeezing. And then the goal in your model is to optimize the likelihood. What is the likelihood? Basically, The likelihood is the probability that your model reproduces your observation. So if your observations are reliable, it makes sense to have a model that reproduces with the highest probability possible your observations. Still, you need transformation, you need a mapping between observations and probabilities. In this case, we use this sigmoidal function. Again, you know what you are doing. I have control of my model and I can know how it works and then make modifications if needed. And then once that you have your model, what you need to do is to learn the parameters that, as I mentioned, optimize the likelihood, and therefore basically becomes just an optimization problem. So basically you can resolve with Newton-Raphson or similar approaches iteratively very fast. This is shown in papers that we have published, so I will not go into details. It's a little bit mathematical, but relatively simple. And you get a mapping like this one in which you can show how that relationship between quality of the rock mass, between demand, depth, for a specific environment, produces an unbiased estimator of behavior in which you can get a good separation between squeezing and not squeezing cases. And not only that, you can also get an indication of probabilities associated to your predictions, if they are reliable or not. One problem very often is that you have some data, but you do not have all the data. You only have partial data. You go to a database. Somebody thought that, I don't know, support was not important. He didn't produce information on that. How can you do that? In that case, the Bayesian networks approach can be very, very useful. You know, basically, Bayesian networks are directed at cyclical graphs in which you develop a relationship between, which is again based on physics or your understanding on the problem. You have somewhat control of what you are doing, and they define conditional probabilities of one definition of one variable based on the others, right? So basically, you discretize the different variables, and you provide what they are called conditional probability tables that, as I mentioned, define the conditional probability of one variable based on observation on the other. And what you have to do is, based on new observations that you have and based on your database, do what's called belief updating, basically get the optimum conditional probability tables to, again, get the best productions possible. You can do that to learn squeezing. This is an example of the results that we get for the conditional probability tables, which again have a physical meaning. You can assess if they make sense or if they don't make sense. And of course, you could do, this is again published in Engineering Geology. You could also use that to predict rock bars, et cetera, et cetera. So that's one topic I wanted to talk. The second topic I wanted to talk is how to use Bayesian approaches to produce or to predict future convergences. Here, one problem, I mean, the prediction of convergences in a tunnel is important. You want to do it as soon as possible if you can, because if you decide that the tunnel needs some reinforcement, it's better to do it during construction, in which you have your equipment there and it's relatively easy to, let's say, for instance, to project an additional layer of shotcrete than in a few months' time when you have finished, everybody's gone, and then it's not so easy to make the improvements, right? So basically, it's very well known that the convergences in a tunnel have the two components. One is associated to stress redistribution when you advance the phase in the tunnel. The second one is associated to rheological effects, basically time effects, in which a rock mass, when it has some stresses on it, with time, it will evolve. And those two components, you know, and this was work conducted in Paris a few years back, they can be separated. So you have the effect of position in the first time here, the effect of rheology on the second time, of the second term, sorry. But in essence, basically you have a model that predicts future convergences in a location and in a specific time, and that model depends on a number of parameters, which is in this case are 4 parameters. This model has been shown to be very, very good fit to real data. I mean, the fit is excellent. But the problem is that the fit is excellent when you have the full observations. So after a few months and the tunnel has been finished, you look back and you say, oh, the fit was excellent. But it's not so useful to look back and to see that your model was excellent. What really is important or interesting is to look forward and see if you can predict what is going to happen, right? So basically, that's what we want to make. We want to see if we can make good early estimations of the future. That's basically the main topic, and how to improve such predictions as the construction goes on and progresses. So basically, we are going to produce a Bayesian approach for that. We will use prior information. And again, here is where the idea that the tunnel is a very long infrastructure is useful, because we will have information of how previous sections of the tunnel have behaved in similar geologies. And basically what we develop is a predictor that, based on those 4 parameters plus a bias factor, so instead of having 4, now we have 5 parameters, is going to predict the observations. And basically we have an iterative process in which, again, we use a likelihood function, and based on Bayes' theorem. Mathematics are a little bit complex. I will not go into details, but they are in the publication that we produce about it. You can look at it. Basically, what we have is an iteration in which we improve of model when we have more observation. We'll just see in just a minute with an example. So here we have an example of the evolution of convergence versus time. This is the blue line is the advance of the tunnel phase, which is basically affecting that redistribution of stresses that I mentioned before. And these are the predictions that we make just after 1 observation, just after 2 observations, etc., etc. So just after 1 observation is this is actually before we have any observation, the prior prediction, not so good, as you see. But when we have 1 observation, so basically, I don't know, I don't remember exactly the data, but maybe 10 days after construction, the second prediction is much better. The third prediction, just 2 days afterwards, is actually quite good. And the fourth one is almost perfect. So basically, we're getting, for a model with 5 parameters, only observations. And in about, I don't know, 20 days or so, we have an excellent prediction of what is going to happen a few months in the future. So basically, also, another important observation of these models is that they can be used to, basically they reduce the uncertainty as you make new predictions. You see, the uncertainties of the prediction initially was relatively high. The second uncertainty was much lower, et cetera, et cetera. So as you make new predictions, you are decreasing your uncertainties. And this has important consequences when you think about this in terms of reliability or probability of failure, because reducing the uncertainties reduces a lot your probability of failure. And also, it has very good advantages, as I mentioned before, in relation to traditional just core fitting approaches, in which for a model with 5 parameters, you need at least 5 observations, if not more, because otherwise you cannot fit a model based on that. So that's another important observation. So to finish, I just showed a couple of statistical learning approaches which can be useful for tunneling practice. In my opinion, they have the advantage that they are visible. You know what you are doing. They are not black box approaches. The results can be assessed beyond the performance only. You can know if they make sense or they don't make sense because you have an understanding of the fundamentals. And they are also attached to the reality, needing few data. Yeah. And then in particular, also I showed I think a new approach based on Bayesian methods that can be useful for site characterization. I have not shown example, but we have also publications and studies on how to use this to predict or to improve your understanding of a site in terms of geotechnics, and also in the context of the observational method, how to improve or your predictions of behavior as you get new information. So with that, that's all. Thank you very much. Yeah.
Thank you very much, Rafael, for this insightful lecture. I remember when reliability started that we geotechnicians thought that this is for us because we are always dealing with ground that is not chosen, is given. And now we see that these machine learning tools, let's say, but Bayesian networks, how interesting they can be for us. And the points that you emphasize on the black box and the Bayesian, that's really interesting. So thank you very much. And now it's my pleasure to have the next speaker is coming from Ferrovial Construcción. If you think the companies that are transforming the world today, most of them probably are high-tech, technological companies related to IT, but also we have the huge constructors and we have huge companies. And if they are there and they have this leading position worldwide, it's because they are doing it really well. And I think that one I'm totally sure that a part of their success is because they believe in innovation. And so it's my pleasure to introduce Inés Ezpeitia, who is the head of innovation projects at Ferrovial Construcción. She's civil engineering, master in BIM, master in project management, and she's going to talk about similar smart tunneling and the use of AI in tunnel construction. So thank you, Inés. The floor is yours. The presentation, I think it's.
Okay, hello everyone, and thank you for having me today. As Nacho was saying, I'm Inés Ezpeitia from Ferrovial Construction, and I'm going to talk to you today about what we're doing with AI in the company. Okay, I'm not going to go into very technical stuff. I think today we have more people like more fit to that, but I'm going to give you like an overall idea of what we're doing and how we're implementing AI in all the phases of our projects. So for all of you, I believe the ones, most of you know about Ferrovial Construction, but just in case, I have a brief video, about Ferrovial. So we are a major company, global company, infrastructures, and we have, we do from construction to operation and maintenance. We have 5 divisions, energy, roads, or Cintra, that's our company, airports, industrial buildings, like CPDs, for example, and of course the construction. Okay, so we work globally, and we are based in Madrid, but also with a lot of projects in the US, Canada, in South America, in Chile and Peru, and also in the West Europe with Poland, France, UK, and Australia. Okay, so we do all kind of infrastructures, and today I'm going to talk to you about what we're doing in tunneling. We have nowadays one of our biggest number of tunnel projects, active tunnel projects. So this is what is making is us to do a major investment in innovation for tunnel projects. So we've been working for the last 3 years in these solutions that I'm going to show you. Okay, so I think you get an idea. So these are some of the projects that we have active at the moment. We're working in Ontario, in Canada, with the Ontario South Line. We're working with Vinci as a joint venture. And this is one of the biggest projects that we have at the moment, and is one of the most innovative ones. We have innovations with them in all the activities. They are also implementing AI in a very, very high level. We have just finished Silvertown Tunnel under the Thames. This was a great project, very interesting. And we were able to see the TBM working, and Thames Tideway also in the UK. And we also have active the Paris Metro, and we are just finishing the Porto Metro and the Sydney Metro. Okay, so as you can see, in the past few years, we've had huge tunneling projects with TBM, most of them, but we also have projects with all kind of tunnel of excavations. So how we are using AI in Ferrovial? First of all, to mitigate, we have a labor shortage around the globe, and we have gaps in all of our projects, and we're trying to use AI to help us, amongst other technologies, to help us to fill in those gaps. We're not trying to push our workers and use AI. We're just using AI to assist and to fill in those gaps, to empower, not replacing the human talent, okay? We're also enhancing the decision-making. We have a huge data strategy in the company, and we're gathering all the information from our projects, and we are starting to use it with the use of generative AI. We're starting to use that information to help our workers to make better decisions. And of course, to reduce the administrative task. This is where we think AI is helping us more at the moment. So I'm going to go through all the phases of a project and show you how we are using the AI at the moment. So for the bidding phases in our tunnel projects, we are using AI to analyze documentation. We have huge projects with thousands of documents, thousands of requirements, technical requirements, 2D drawings. So we're using AI. Our bidding department is completely on board with this and using AI to analyze this information. And we're having huge benefits in this. We're also leveraging historical data to have our biddings more competitive. So we have been gathering for the last years all the information we have for our tunnel projects. In Ferrovial, we have done more than 500 kilometers of tunnels. So you can imagine the information, the data that we have. So we have been speaking with all the project managers. They had servers, they had their hard disk and their computers. So we've had people gathering all that information, and we have a data warehouse where we are storing all the information. Digitalizing also, we had a lot of information in paper. So especially for the TBM projects, we have thousands of data from our sensors. So that is what we have been gathering. And we are using it now for predictive analysis and cost. So we have information from our projects in the last 30 years of tunnels. So we're using that information to improve our biddings, okay? So the costs and the times of the projects, we can improve that with the AI. And of course, the automation of the bid preparation with tools that help us to better prepare our bids, taking into consideration documents and information that we have prepared in the past. So as you can see, this is the savings that we're getting only for 1.5 years of using these tools. So we're getting 30–40% time savings in document analysis, 10 and 20% reduction in cost and times in our projects due to historical data analysis with AI. And we're also having reducing the cost and the time of the writing of our tenders. So as you can see, the use of AI in this phase alone is already worth it, okay? So for the next one, the design, we have been using BIM for more than 10 years now in the company. So we have already, all our departments are using BIM from the bidding phase to the design, construction, and handover and operation phase. So it's something that we have integrated completely in our core. So we're now leveraging that BIM with AI, okay? So we're including generative design to better design all of our projects, not only tunnels, but all of our projects. We're using data-driven design to better improve our geotechnical analysis. So you've seen a lot of presentations today regarding this. This is one of the main issues that we have in our tunnel projects, the terrain. So we're making all kind of trials of new technology that can help us to better understand what kind of terrain we have in our project. And then with all that information, we're using 3D models to better predict what is going to happen in our projects, okay? And of course, the design review. We have a very big BIM models, so we're using AI now to better review those models, because sometimes we don't make them. We have designers make them. Sometimes the client gives them to us. So we are using AI to better understand the models and to better get information from them. Sorry. Okay, so we have gone through the bidding and design phase, and now we're moving to construction. So how are we using AI in our construction projects? We have, as you've seen in the previous slides, we have projects that are huge with hundreds of people working on it, thousands of documents, drawings, 2D drawings changing every day, BIM models changing every day. So we are creating specific tools, our own chat GPTs or chatbots within our projects that can access all the information of the project, all the technical information, so it can help our team to better look for the information, because we saw that we were wasting so much time looking for information. We were using data and 2D drawings that were not updated, were not the latest versions. So that took to errors in the construction phase. So with these chatbots, with these tools, we can access all the information. We can connect through APIs to all the tools that we are using in the project, both in field and in back office. So we can have everybody connected. So here you have two examples from the Ontario project and HS2 project. These are two tools that we have developed, but we have others. I mean, we're using, for example, Copilot, Microsoft Office, in all of our projects. So you can see we have had an over 50% of more certification in the HS2 project, thanks to using this information, okay? Because we were able to gather the information very easily. And also in the tunnels, how are we using AI? Okay, so this is not news. You know, all the companies or our competitors, we're trying to do the same. Acciona, Vancy, all of us, FCC, we're all doing the same, trying to gather information from our projects to create a connected tunnel. So we have our Smart Tunnel program that we are creating this in our projects. A network of all the solutions, everything that we have installed in the tunnel is connected, and we're gathering the information. We have a lot of people that have been working for more than 30 years in our tunnels projects. These people are retiring. So with AI, we're trying to gather that information and to use that know-how, that experience, to help the new people that are working for us to better work and make decisions in our projects. So as I told you, we were gathering information from our last 30 years of tunnels. We have our data warehouse, and now we're working with that information. So we have created our own platform that connects with everything that is installed in the tunnel through APIs, PLCs, and our own systems. We're gathering that information, and we are connecting that information. That is the key, to connect everything. For example, to connect consumptions from our TBMs with the terrain, so we can see with different terrains how the TBM is behaving. We can also better assess the risk in our projects, because, for example, we have a shortage of rings, for example, because of logistics problems. So we know we're going to have an issue in the process, in the construction process. Or, for example, we're using bentonite plants, for example, that need to work like a clock, so we can keep the excavation with the TBMs. So we are also monitoring those plants to see that everything is moving smoothly and the project is not going to have any issue. We have real-time data analysis. So apart from the guiding tools that we have from FedNet Connected, for example, from the connected tunnel TBMs, or of course our competitors, Vancy, they have CAP. We are also using that. So apart from that, we are gathering information from other systems in the tunnel, so we can connect the information from the TBM and the rest of the systems of the tunnel. So this is some views of our platform. I'm sorry, I'm not able to show you more. It's high confidential. I know some of you are taking pictures. Basically, you can see part of our projects, and then we have different dashboards with information. This is real-time information that we are gathering from the different systems, okay? And then we are adding this know-how, this implementation. Apart from this data from the TBM, we're also implementing other technology in our tunnels. So we have autonomous equipment and robots more and more in our projects. So we have some trials with autonomous equipment, and we also have robots that are already being used in our sites. So this is, for example, our tunnel in Silvertown that I showed you earlier. With our colleagues from BAM, we were in a joint venture with them. We did a test with the Boston Dynamic robot to do the quality assessment of the tunnel before the end of the works. But we're also using autonomous equipment. So we're seeing that in the future, our tunnels are going to have less people inside, so they're going to be safer. So we need to control everything that is happening in the tunnel. So we're placing fixed cameras, we're connecting with all the systems, with all the equipment and the robots that are going to be working there. And so in the future, we're prepared to know everything that is happening in the tunnel. And of course, health and safety is a very big issue. So we're starting to use AI cameras to better detect what is happening on site. So these are, for example, fixed cameras. This is an AI render, but we are testing them now to see how we can use the fixed cameras to analyze what is happening inside the tunnel, how the machines are moving, how is the production, if we have any health and safety risks, to scan the materials, okay? We're also using it for the logistics. So we're using AI cameras to know exactly how many trucks are going inside the site, what kind of material they're bringing, also the material that is stored. We have a major issue in our Ontario project. For example, imagine a huge project where we're going to have 100 trucks coming out of the excavation every day, and they have to go through Ontario, which is going to be crazy. So this is a major issue that we're trying to solve before they start the excavation in April. So we're trying to use AI to simulate the traffic to better understand how the traffic is behaving, so we can change day to day the way the trucks are going out of the site. So as you can see, we are not using AI only in the tunnel, but outside the tunnel, because all these activities are going to impact the excavation. If something goes wrong outside the tunnel, then the tunnel is going to be stopped. Okay. We also have like thousands of sensors placed in all Ontario. It's like crazy, all the buildings, everything, we're monitoring everything. So this is a huge amount of data, and we need to be able to integrate what is happening in the surface with what is happening down there in the tunnel, okay? So it's not, I mean, I'm selling it like it's so great, but we also have like a lot of issues. The technology is, you all know the technology is changing. Every day, every month, we have different solutions coming out. We're working with Bentley, with Autodesk as well, I'm sorry, with different startups that they're developing solutions. So we're working with them to see how we can integrate those solutions within our own systems. But I mean, the cost of the AI solutions at the point is quite high. So we're trying to work with what we can. We have very limited geotechnical data because we haven't been storing that information from all of our projects. So we're trying to find out how we can help and how we can work with external companies to have more information, because the geotechnical data is going to affect everything that we do in the tunnel. We also have a variability of the terrains and the TBM, so it's not easy to use AI and to be able to predict what is going to happen in a project, because each project is completely different. So this is a major issue that we're having. If a project has like a very homogeneous terrain, it's easy, but sometimes we have projects where the terrain is changing, the geology is changing all the time. So in those projects, it's very hard to predict. And we also have the resistance to the change, and of course, ethical and safety concerns with AI. At the moment in Ferrovial, we're having like a major issue with the data, cybersecurity, IP, and all that in the past, maybe we didn't think about that. So this is complicated, the contracts with the suppliers. We see solutions that are very good and could be very good for the company, but maybe we are not able to use them because of the cybersecurity and the data confidentiality, because our project data is like a treasure for us at the moment. So it's what's going to give us the competitive advantage. So this is mainly what I wanted to tell you today. Sorry, I didn't go very deep into anything, but I'm not able now. Something that we are working all our competitors. So I hope you get an idea. And if you need if you want to know more, you can write to me or you can talk to me later, and I'll try to answer the questions. Thank you.
Thank you very much, Ines. Despite the issue with the industrial secret, I think that we all have are more aware of the value that your company is putting on these techniques. So it makes us aware that they are really promising technologies. So thank you. I hope that sooner than later you will prepare the bid and we'll do the design and we'll construct the tunnel in the Gibraltar Strait. But we need to wait for that. So the next speaker, now we go again with another company, an engineering firm. It's my pleasure to introduce Eloy Paris from Senent, another huge engineering firm, and he's going to talk about the use of AI during the tunneling process. So thank you.
Okay, thank you, Ignacio. Thank you, everybody. Hi. I will continue to talk about the tunneling, but more focused in the artificial intelligence application and in the assessment and the service needed for risk mitigation in tunneling, not only during the construction construction phase, also in the maintenance part. The context, I think we spoke about this in this two sessions. The cities now need more services as metro, as light rail, etc. And the issue is construction in a safe way. And for a safe way, the TBM still, or maybe is the unique preferred method right now. But it's the preferred method because it's considered the safest, the most reliable actually, but it's not exempt of risk. Risks are very present in the community, has a huge impact in the community, can cause a heavy economic losses and damage, a big damage to the public image of the administration of the construction firm. Two figures, but also I want to highlight, I always highlight these two figures. More or less, these figures are from 2017, are a little far away, coming from for insurance companies. 40% of incidents in tunnel construction occur during caused by TBMs. Because, of course, now it's very extended the implantation of the TBMs. The number of incidents about this is huge. But the other figure is more interesting because the average delay is more or less could be a 1 year in average. What this means? It means that we have this impact in the community, economic, and in the public image of the participants. Some examples, not so far away in time, in Poland, 2024, in Sao Paulo, in line 6 in 2022. This was a huge sinkhole which affected a highway, one of the main highways of Sao Paulo. And more recently in Thailand, during the Purple Nighttime construction, a huge, really huge sinkhole has been produced very close to a station. That means that the risk is always present. Doesn't matter it's a TBM, and this risk we have to manage in such way.
And one of these ways is the data analysis. Data coming from the machine are more or less since 2000 are very common in the tunnel boring machines. We can register a lot of parameters, 400 each 5 seconds. That means that we will have at least more or less, depends on the manufacturer, depends on the machine, depends on the project, depends on a lot of things. But let's say a figure on average is more or less 7 million data values can be produced in just one day. This is a huge amount of information. Of course, first, before the analysis, we need to manage this information. We have to know what is this information. The first point is the raw data. Raw data coming directly from the sensor of the machines are the values without any transformation, without any processing. And now there is a lot of ways to visualize. Every manufacturer have their own platform, their own software to visualize the data. Also can be recorded in very easy way in a text file or a CSV file, and everything of this in this site is solid, I think. But if we stay in the raw data, we can go further with this data. This data can tell us a lot of things. For this, the first point is processing this raw data. I always mention the same example. A mistake, an error in the date of this data, or maybe in the number of the ring, because let's say the transformation is by rings, can modify, can distort complete the analysis further. This is the first point. Identify these errors, these mistakes, correct it if it's possible. Sometimes the files are totally corrupted and we cannot work with it. But the first point is reduce these errors. The second point, I go a little back. I go back. Also, in this stage, we must to filter this data. Okay, we have a lot of information, but not all the information is useful for our analysis. In each part of in each section of the drive, in each section of the excavation, there are some parameters that are critical, the key parameters. We have to extract these parameters and the ones that is related to this parameter. Let's say, first of all, to speed up the analysis, and then to concentrate the analysis in this data. This is the first action we have to take before the data processing by algorithms. These algorithms are very nice, but are not alone. There is analytical, there is an expert in the back of this analysis. That means that in a tunnel excavation, there are a lot of things that are not registered in the log register of the machine. For example, let's say a cleaning of the mortar lines, an injection of water without register. A lot of things that are not in the control of the machine are in control of the log. This must be taken account for these algorithms and for the expert. Right now, at the moment, we think that there is always an expert behind these algorithms. And then the point that, okay, we have all the data processed, filtered, computed with the calculation algorithms, etc. We must visualize, but this visualization cannot be the same that we can that the visualization we have with the software of the manufacturer. This is the raw data with all the error without any processing. Here we have to display the relevant information. Relevant information is, for example, with an APV, it's very critical the weight excavated, the volume, the grout. These parameters must be associated and allow a good visualization for the expert. And with this visualization of quality data, we can place our decision, but base it in this data at the end stage, not in the data at the first stage. This is an example of analysis platform, not a software that is coming with the TVM. There is another point I think we talk about in this session, is the integration. Only with the data coming from the TVM, I think it's not enough. We need more information. There are more information around a tunnel boring machine excavation. Information coming from the project, for technical, for example, the abrasivity, all the information coming from the project. The specification from the TVM. We spoke about the information coming from the PLC screen mirrors coming from the TVM directly, and the instrumentation we have placed all around the drive. All this information should be integrated in one platform, in one tool for the expert. Sounds easy, but right now we face a lot of examples with constructor and with TVM manufacturer. But this is not already implemented. That is, everybody has his own platform, and you have all the information in different sources. This could be a nightmare in the case you have an incident, you have an emergency. This could be a nightmare. For this thing, we think that this is a better way to show the information to the analyst. And to finish, I think they spoke about a lot of this in this session. There is a challenging project right in Madrid. As you see, it's in the middle of the city center of Madrid. So we have the station of Atocha, the station of Sol. It will cost the M30 2 times in the south, more or less in the southwest and in the southeast. Buildings, infrastructures, everything. This is a typical case of challenging project in third-party risk. But okay, we already built our tunnel, dismantle the TVM, breakthrough, everybody is happy. But now it's coming another stage. This is the operation. We need to give life to our infrastructure. And this infrastructure suffers a lot of. There are a lot of defects that can be produced. The management of these defects is these pathologies could be really a nightmare. For this reason, we think we have to implement a digitalization for this process. The first stage is objective. Be objective with the criteria, with the classification. Try to give parameters to the defect. Automate the data caption. This is very, very interesting and very important because I think the people who make inspections knows very well that they spend a lot of time in the tunnel taking notes, taking pictures, let's say then passing this information to an Excel file or computer, reorder again. This is a lot of time, and sometimes it's very unproductive because there is no relationship between a single photo and the defect we are taking on site. The automatization tries to solve this issue. In this point, we are in the stage of the information. We are transforming this data in information. This is the first step to digitalize the management maintenance, and then to work or to evolve to a predictive evolution of the tunnel, a predictive maintenance. For this, in Sener, with the ACROT service, we developed some tools to help the metro carrier to perform this maintenance. The first is an application for the tablet for for a mobile phone, for a smartphone, that allows the inspector to take notes basis in a objective close criteria. That means there is a common problem. There's, for example, two inspectors in different times take the same defect with different criteria, with different evaluation. At the end, you as an analyst or you are as of the responsible, how we know which is the real risk of this defect. With this, we try to avoid this. Also, we eliminate the time that we spend after the inspection to go to the office, take the notes, pass into a computer, reorder the photos. We can relationship the photos directly. That means that this is an evolution of the normal inspection. But if we can, sorry. But we can go further. We can go in automated method. We already developed also a LiDAR-based inspection with thermography camera that allow us record. Recording is not the best. My colleagues say that the record is not the best word for this, but anyway, record a point cloud of the tunnel and detect moisture, water leakage, but not only detect, also quantify. This is a direct method that gives us the result just after the inspection and eliminates the presence of the human inspector. We prove, we tested in a real metro line with very good results. We can inspect more or less 2,000 meters per hour, depending also the condition of the tunnel, if we have open track and so on. But the method is really reliable, we think. And again, all this data we must put in let's say in a good tool for the final user. And with this, we propose to pass from a bunch of paper, from a bunch of report, for a bunch of drawings to a digital management. That means that all the information is in one site, one place. We can filter, we can print reports if we want, but we have access directly to each defect, which each pathology in a very fast way. That means that the metro carrier have a good knowledge of the state of the infrastructure. Of course, and coming back again to the first slide of this part, is based in a totally objective criteria, classification, and the risk leveling. And to finish, summarize a little bit let's say the benefits and the main points of this digitalization we propose. The risk mitigation in the complete tunnel life cycle from the construction to the final maintenance and during the operation. Integration, very important, because as we mentioned in the construction part, in the phase normally we have a lot of sources of information, and sometimes these sources are not related between them. It's a bit for automatization and digitalization, but the automatization also always with the point of view of an expert. We cannot forget that as we mentioned before in this session, we need a lot of training for the algorithms. We need a lot of data, and sometimes the data, for example, in the construction of tunnel construction, are
could be limited because we know the manufacturers and the companies are very tight with this. They don't. They are not very open to share this data. And the figures we calculate more or less. We need more experience. We need to go in a little bit ahead with this, but we think we can reduce more or less 80% of office work. And for example, in the first test we did, it was like this more or less. That means that the automatization and digitalization is, I think, is coming, could be applied in the future, but as I said, that without an expert in behind at this moment. We will see in the future, but at this moment, I think the expert should be in top of this. And that's it.
Thank you very much, Ale, for this presentation, highlighting how you embed data-driven processes and how you approach digitalization in Senent. I must thank you because this is the second time that you accept the invitation, and I take advantages of this to announce that we have a YouTube channel in which you can find many webinars. There is another one from Eloise, maybe it's longer, but also we have webinars on the extensions of Paris subway lines, on how they are using digital twins. And the next speaker is coming again from AGESA, but it's a totally different approach. It's not related to the design, but to the operation and management of the tunnel. He's Carlos Rodriguez Alonso. He's mechanical engineer. He's an alumni of our master, the master. And I also like to highlight that. Are you going to talk about Fanega Tunnel a little? Or? Yeah. Okay. So one of the cases that he's going to present is one of the capstone that the learners of the last edition of the master developed. So it's a real case of a digital twin for a tunnel in operation. So I think it's interesting. And we also want to highlight the high quality of the capstone project that this master is promoting. So thank you, Carlos. The floor is yours.
Okay, thank you very much, Ignacio, and all the event. So we will be talking about how the digital twins are transforming tunnel operation and maintenance. So our agenda will focus 3 cases. First, we will talk about AGESA digital twin vision and the technology enables that make it possible. Then we will focus on the key use cases for operation and maintenance. We will talk about the most impactful use cases that we have identified. And finally, we will talk about the cases too, the Media Fanega tunnel, that is the capstone that was developed last year in the master degree. So first of all, we'll present AGESA. Some of you may know it or not. So we are a global engineering and IT service technology offers. We are top 5 in IT service provider in Spain and in the 15 of world's top engineering firm by revenue. We have a turnover of 800 million last year, with more than 14,000 employees around the world in 24 different offices with 17 different nationalities and with a lot of disciplines. So our vision of digital twin is that the digital twin is not a 3D model, it's a virtual replica of a real process, system, or asset, filled with maintenance, health, and improvement in and performance, information that could be used with new technologies to generate value and improve decision-making. That is the real value of the digital twin, the improve of the decision-making and the value it generates. So, and which technology make it possible? Well, we talk about AI machine learning to explode all the information that is gathered by the sensor and by the real assets. Then IoT and cloud computing with get us access to that real-time information, the real system assets information, and the computing capacity to process of all that data. Last but not least, cybersecurity. We have been working in silos of information with the SCADA that was not connected to the network. So now we are connecting that information to internet, and we need to assure its security. So cybersecurity is one of the pillars of the digital twins. So how we do apply this technology to digital twins in tunneling, operation and maintenance? Well, we are talking about two branches. In the maintenance side, we will try to optimize maintenance via proactive. We will try to transit from reactive to proactive maintenance. We will use predictive maintenance to tunnel equipment like fans, lighting, to avoid problems before they occur. We will be using real-time anomaly detector to prevent that a problem in some equipment could cause fatal failures. And other thing that we could use with a digital twin is tracking tasks or automate critical error on critical system. On the operations branch, we will try to move from reactive again to prescriptive. We will want to know how the system needs to operate to reach our objectives, okay? So we will be focusing on prescriptive model for smart ventilation. We could relate, look for the relationship between the traffic, the last hour traffic in the tunnel with the air quality to tune the ventilation system and don't reach alert smart ventilation, air quality range. We could also work with traffic flow prediction to schedule maintenance tasks, avoiding to reduce the normal traffic in the tunnel, and planning maintenance in low traffic windows. So now we hit to a real cases to the Media Fanega tunnel. The Media Fanega tunnel, as Ignacio already said, was a collaborative project between the AGESA, the master degree of digital twin for infrastructure and cities, and the Ministry of Transport of Spain. In this project, AGESA leads the system architecture, integrating geometry models, and also guide the students on the machine learning model that they have developed. The goal of this project is to use real-time data to simulate and predict lighting functions and traffic flow to optimize the maintenance and operation of the tunnels. So why AGESA and why the Media Fanega tunnel? Well, we have been through the whole life cycle of the tunnel, of this tunnel. We have been involved in tunnel design. During the construction phase, we have been as site supervision, assuring the quality of the construction. And now in the operation and maintenance, we are responsible for tunnel security. So we have the knowledge of all the stages to find the best models for these digital twins. So the challenge, we made a visit to the tunnel and talk with the maintenance staff to see what challenge do they face in the normal day operation and maintenance. So they talk about one critical failure that they are having is about the lighting functionality, because it was based on a sensor outside the tunnel, a luminosity sensor, that only relates to the sun. So we have sometimes when there are scattered clouds that it's changed its functionality range very quickly, making this lighting to reduce if it's light, is completely light, and also wasting a lot of energy. Another of the challenge they face was the flow pattern, different flow patterns continuously in the tunnel that don't allow them to schedule the maintenance tasks correctly. So what have we done? Well, our solution is a machine learning powered decision layer, well, where we have fused first the information of the sensor inside the tunnel, the illumination center, and all the sensors, the CO2 and all other sensors that the tunnel have, combine it with external information from up, like weather predictions or traffic flow downstream, different information. This information, the combined information, is used to train the machine learning model. And once the machine learning model is trained, we had exposed that model in an API for real-time prediction. This real-time prediction allows us to establish the different functionality range for lighting operation and for the flow pattern, for the scheduling of the tasks, maintenance tasks inside the tunnel. So these are the models that was generated by the student. One was the lighting optimization model that use the algorithms HGB boost that allows us to predict the luminance 1 hour ahead using the previous information of the luminosity sensor and also the weather API checking the cloud coverage outside the tunnel. This model allows us to establish a stable operation of the lighting system inside the tunnel, avoiding cloud filtering and reducing the change. The other model developed was a traffic prediction using CatBus algorithm that again predicts traffic volume 1 hour ahead, allowing for proactive ventilation functioning and scheduling of maintenance tasks. So with this model, we have talked before that the main objective of the digital twin is to generate value. So we have carried out a return of investment study in we had different concepts. We had established started from different cases of a tunnel of this size that the investment in the tunnel for this digital twin for this model will be around 70,000 euros in the software development, the hardware, the models, and in cybersecurity. Then it also adds the maintenance, the year maintenance, that is around 3,000 euros a year, about license and maintenance on the different hardware systems and readjusting the models. And then what are the savings of this digital twin? Well, the saving could be translated into energy consumption reduction for the lighting operation in around 15 to 25% that will be translated in 4,000 euros a year. Also integrating this digital twin with the operation of different digital twin from tunnels in the ministry in a single platform will help us to reduce the staff costs of the operating and maintenance, saving around 25,000 euros a year. And then also the predictive maintenance and the stable operation of the lighting inside the tunnel could also help us reduce the corrective maintenance tasks, changing the lighting inside the tunnel. So this is the global amount, the saving and the invest, showed a return of investment in less than 3 months and with a saving of over 30,000 a year. So that's why this is very interesting to do. So further steps that we are developing in AGESA is developing that integrated platform that could contain this digital twin and another digital twin tunnels, and also exploring other models like the ones that I've already told, that relationship between the traffic flow inside the tunnel to the air quality, to use this air quality prediction to adjust the ventilation task and the ventilation operation inside the tunnel. So that's all. Thank you very much. If you have any questions.
Thank you very much, Carlos, for this nice presentation that explained very well what a digital twin can be for an infrastructure, and that also highlights the impact and the return of investment that is something really important for the implementation of these technologies. So we are a little behind schedule. I think that we will be able to shorten maybe the last discussion. But before that, it's my pleasure to introduce one of the last speakers today. The last speaker, I think. As you know, this project is, as I said, it's a joint project from several universities in Europe. We have a very close relationship, this school, the Escuela de Caminos, with École Nationale de Ponts. So it's, for me, it's a pleasure when every time that we invite a researcher to deliver a keynote lecture, but especially she is coming from École de Ponts. So I think, unfortunately, she cannot be here today in presence, but she will be online. So I hope that, should I do anything, is Lina Maria Guayacán Carrillo, from research scientist at the École Nationale de Ponts. What should I do? Okay, nothing. Hello, Lina. Can you hear us? I'm sorry for the delay. We are a little behind schedule. We cannot hear you, so
hello, can you hear me?
Yes, now we can. So okay. Yes, so we can see your presentation, we can see you, we can hear you. So thank you again, Lina, for accepting the invitation to deliver this talk. The floor is yours.
Thank you, Ignacio, and thank you to all the organizers for this invitation. I regret to not be able to be in presence today, but I'm grateful to participate remotely. So today I will talk about the synergy between the integration of in-situ monitoring, numerical simulation, and machine learning in tunneling. This work has been developed in collaboration with my colleagues Jean-Michel Pereira and Jean Zulem, and with the participation of PhD students Tatiana Ruisha and Alex Cristani. So, in the presentation today, I will focus on 3 main points. The first one is about data acquisition and generation. The second one is the use of machine learning models with a small data set. And the third one is to look for a possibility of use incremental learning and interpretable tools for the tunnel design. So, beginning with the first part of the presentation, the first challenges in using new methods for advanced numerical modeling, in particular machine learning, is the data sufficiency. And here we are talking about the quantity, but also the quality of this data. So it is very important to improve the protocol to recover this data in situ, but also to generate the asynthetic data that will be reliable to help in the design of the structures. An important point that is often forgotten in some projects is the importance of creating a sufficient database for an easy, fast, and secure data availability and access. Hydromechanical characterization of host formation are mainly monitored by instrumental multiple boreholes to track the pore pressure evolution, the permeability variations, and also the formations around tunnels. We also use monitoring of geological boreholes, mainly to see the evolution of the fracture zone and used by the excavation. And the most used measurements, the convergence measurements along the tunnel. This measure is really easy to do and is not expensive. This is why it is the most common measurement performed during tunnel excavation. And we will install different sections through the tunnel. For people who are not familiar with convergence, in a few words, the convergence is the relative displacement between two opposite points of the wall in a tunnel. We try to follow this evolution in different directions of the cross sections in order to see if there are an anisotropic deformation around the tunnel. It should be noted that the convergence evolutions depends on two main factors: the influence of the tunnel phase and the time-dependent behavior of the ground. In fact, if we are very far for a considered section or during the interruption of the tunnel excavation, we can observe that the influence of the phase advance is attenuated, and it is this biological behavior of the ground who will perform and who will impact this convergence evolution over time. As you see in this example, we are dealing with data that is sparse, that is noisy, and sometimes we have missing data. And this missing data is mainly related to in situ constraints, related to obstructed access to a monitoring area for a period of time, problems with the sensors because we have a failure of a sensor, or even if we don't have sufficient lighting in the section considered. So we should bear in mind that for the analysis of in situ monitoring data, there are three key points to consider. The first one is that are available in space and time. In fact, as I explained you before, the evolution of the deformation around a tunnel depends on the variability of the ground, but also depends on the time-dependent behavior of the ground. These data are diverse. In fact, in a tunnel construction, we have different kinds of data. For the specific case of a geotechnical project, we can divide this data in four types. We have a data related to the characterization of the geological and geotechnical parameters of the ground. We have data related to the time-dependent interaction between the ground and the lining. We have data related to the operational activities during the excavation, and also the data related to the temporary supports and final line. And finally, we have data that are derived from human activities and are inherently dependent on human decisions. And it is an interesting point to keep in mind because it is the point that is often forgotten in the analysis of in situ monitoring data. For example, the parameters of a TBM machine will also depend on the decision taken by the operator. So it is really important to improve this flow of information during tunnel excavation to have real in situ data in real time, but at the same time have the possibility to analyze this data, taking into account with all the situations that are happening during the excavation. And concerning the data generation, in the field of tunneling, we can think on two usage scenarios. The first one is related to the data generation on the basis of collected data. So in a few words of background, the characterization of the ground behavior is really difficult, and in most of the case, an in-depth characterization is performed after the end of the excavation. So the question is how we can generate data based on the in situ monitoring that starts from the beginning of the excavation. For that, in the thesis of Alex Pesani, we have proposed a methodology based on 4 main steps. So the first step is to consider the first convergence measurements that we take in the field. Then, considering the semi-empirical law, the semi-empirical law of Zulem et al. Proposed in 1987, and that has been very well presented by Professor Jimenez, we will try to estimate and reproduce these convergence measurements that we have recorded. Then, based on the calibration of this law, we will extrapolate the convergence evolution over time until the period decided for extrapolation. And finally, we will use this extrapolation to do an optimization problem where we will consider the convergence at each point, but each point represents a convergence at a different time and also at a different position corresponding to the tuning phase. And we will estimate the set of parameters taking into account a behavior law that we like to consider to simulate the behavior of the ground. And we will obtain this set of parameters that best perform this convergence evolution over time. What is interesting with this approach is that with this set of parameters, now we can do a lot of simulations taking into account different superstructures in order to have a better idea for the optimization of the tunnel design. The second scenario is the data generation on the basis of numerical simulation. So I will come back to this second point in the following of the presentation with a specific case study. But before present this part, I will go to the second part of the presentation, the use of machine learning models with small data sets. In fact, in geotechnical projects and in tunneling, even if the technology has improved the situation, we are dealing with a small data set in comparison with other fields as robotics and computer vision. So the question is how we can have reliable models that doesn't overfit the training data. So for that, I will show you here a specific case study for the creation of surrogate models. So first of all, where is a surrogate model? In this case, this surrogate model is only a model trained using machine learning tools based on synthetic data generated by analytical solutions or numerical simulations. So here the idea is to create synthetic models in order to allow the engineers to reproduce different case scenarios in a short period of time, and in this context have a better idea of the weight range of situations, considering a weight range of geological conditions and superstructures. This specific example comes from the thesis of Electricity, where we have considered a 3D numerical simulation for different case studies, considering elastoplastic ground and viscoelastic ground. In this project, we have proposed to use the ensemble bagging models correlated to the artificial neural networks. So these ensemble models, the ensemble bagging models, are based on bootstrapping, which is a resampling technique used to access statistical accuracy by sampling with replacement. Then the performance of the model is based on averaging a model prediction over several weak learners rather than a single one. This method seeks to reduce key shortcomings of standard algorithms, statistical, computational, and representational. In fact, by building an ensemble of weak learners, the algorithm can better explore the search space and average the votes of these submodels to find a good approximation of the two unknown functions. Here I show you the results that have been obtained considering an elastoplastic ground, and we can observe here the prediction at the equilibrium state. So we have the radial displacement and also the orthoradial stress in the final line. What is interesting to highlight here is that similar conclusions in the use of these ensemble methods with small data sets were found for another case study concerning spatial extrapolation. So here, this is a part of the work of the thesis of Tatiana Risha. And in this work, we have explored the use of ensemble methods to predict the maximum settlement and use by the passage of the tunnel boring machine on two lines of the Grand Paris Express projects, which concerns the extension of the Paris Metro network. In this specific example, the aim is to estimate the maximum settlement in zones that have not been yet excavated. This makes it possible to detect in an earlier stage if the deformation exceeds or not a critical threshold. It is known that these kind of tools should not be used outside of the range of parameters used for training. But in a project as the Grand Paris Express, where several lines are constructed in similar geological horizons, we can benefit from the so-called spatial extrapolation. However, when it comes to tunnel projects, there are two main issues that need to be addressed. The first one is that data comes with the excavation of the tunnel. So here we need a tool able to learn incrementally as new data comes in. In a second point, there is a need to consider interpretable tools. In fact, engineers are responsible for the design, for the decision of the final design. So engineers are more comfortable with tools that provide transparency and interpretability. For that, we have explored the applicability of the symbolic regression approach in a real-time monitoring to predict convergence evolution. Symbolic regression is a well-known approach that attempts to identify and optimize mathematical function as simple as possible to fit and extrapolate the data. It is interesting to highlight that this main approach doesn't make any assumption about the structure of the function. And also we will see if it is possible to capture the spatial-temporal main characteristics of convergence evolution. For that, we have proposed a methodology step by step, where we will estimate the convergence at time t based on the information of the previous measurements performed in the field and also in other 4 parameters. A parameter related to the time after the passage of the phase, a parameter related to the distance to the tunnel phase, a parameter related to the ratio of anisotropy of the initial stress state, and finally a parameter related to the direction where the convergence measurements have been performed in the cross section of the tunnel. Then, a typical model is developed by creating an initial population of computer models. These concrete a randomly selected set of user-defined functions and terminals that are arranged in a tree-like structures. The more complex models have a lot of subtrees that are connected by a special node called root, and these nodes allow these subtrees to interact and exchange information between them. Then the optimization problems will look to identify the best candidate mathematical expression that better describe this relationship between the 5 input parameters and the convergence at time t. We should keep in mind that this approach should be able to reproduce with good performance the data used for training, which means the convergence recorded during the first day of excavation. But also this approach should be able to forecast data using during the training phase, which means the convergence evolution over time. So for that, we will also do a step-by-step procedure. We will start by the convergence measurement at time t to estimate the convergence measurement at time t+1. Then we will take this estimate value to estimate the convergence measurement at time t+2, and so on until k bar. And today I will show you the application of this methodology to a specific case study. This is the drifts excavated in the Calo Oxfordian claystone. This drift present a very interesting anisotropic deformation that depends on the orientation of the drift. We have observed that for drifts following the direction of the major horizontal principal stress, where the initial stress state on the cross-section is quasi-isotropic, that the horizontal convergence is 2 times higher than the vertical one. For drifts excavated in the perpendicular direction, where the initial stress state is anisotropic, we have observed that the vertical convergence is 4 times higher than the horizontal one. In both cases, we have observed that during the first 100 days, we have a high evolution of the convergence evolution, and then convergence rate tends to stabilize with time. As the objective here is to see the accuracy of the convergence forecasting based on the in-situ monitoring, we have tested different periods of time. So here I show you the estimation considering only 40 days of monitoring and then considering 200 days of monitoring. As you can see, with more days of monitoring, we will have more accurate results. But what is interesting to highlight here is that with more days of monitoring, the forecasting, the mathematical relationship obtained for the forecasting is a simpler one. And this is related to the fact that in this case, it's more the rheological behavior of the ground who is playing a key role in the convergence evolution. So we can obtain a more simplified expression, which depends on 2 main parameters. The parameter related to the previous measurement. So this one will help us to obtain information about the anisotropic evolution and also the dispersion along the tunnel. A parameter related to the time after the passage of the tunnel phase. And then we will have an exponent and a constant that will depend on this case study. So we have observed that this is a dynamic method that allows the user to refine the forecast as new measurements become available. And finally, I'd like to highlight that for the first time for this project, we have obtained a unique relationship that accurately describes the observed data in both directions of the formation in the cross-section of the tunnel, but also, and the more important result here, is in both directions of excavation. So, as a general conclusion, we have observed that this data-driven machine learning approach will not replace the fundamental on which the field tunneling has been based to date. But these new tools appear to be a promising complement that, when combined with the others, will help the field move forward by combining the strength of each one. They will enable the engineering community to improve and speed up the two-way flow of information needed to make decisions on the final design, monitoring strategies, and maintenance of measures. Then, to sum up more specific conclusions, we have observed that ensemble methods have good performance and reliability in achieving accurate prediction despite the limited data set that we have in tunnel projects. Machine learning surrogate models offer useful advantage for practical tunnel applications. In fact, once trained this kind of model, we can have results in a matter of seconds. We have observed that also the spatial extrapolation has been shown to be feasible and helpful in some kind of projects, and that interpretable and incremental learning tool seems to be a promising option that allows to obtain a simple, free-form, interpretable, and generalized expression. So this is all for today. Thank you for your attention, and I remain at your disposal. If you'd like to discuss further on that, you can contact me by email. Thank you very much.
Thank you very much, Lina. It is a pity that you are not here to continue the discussion in person, but maybe now you can participate if the technology allows us for that. In the round table, I think that we will have a last discussion with the speakers of the last session. So I can call you. It will be moderated by Professor Jimenez from UPM, and we will come with the participation of Eloy Paris from Senent, Inés Azpeitia from Ferrovial, Professor Romana from UPM, and Lina, if she can stay online and the technology allows for that, from École Nationale de Pont-et-Chaussée. Thank you.
Well, good afternoon, everyone. We are going to start this session of discussion and interchange of ideas. So first of all, I wanted to say thank you to the people that are going to share the floor with me, and also to Lina, which is in the distance. Hi, Lina, if you can talk, please feel free, and you are more than welcome. I can barely see you, but just raise your hand, say that you want to speak up, and we'll introduce you, okay? And of course, I also wanted to open the discussion session to the floor. I mean, I think basically one of the main benefits of this type of events is that people in the audience can also provide experiences, comments, I don't know, even questions, whatever you need, no? So I think the idea is that I'm going to just introduce a few topics for discussion, and I will leave the speakers to share their experiences, their opinions, and also, as I mentioned, the floor, no? And I think the first thing I wanted to introduce is that maybe we should discuss a little bit about data, no? I think maybe one of the key learning outcomes of this session is that in the future, or not, even now, no, data is going to become knowledge, and data is going to become, let's say, power or competitive. It's going to give also how do you call it, like a differential advantage between companies. And so the key question is, how are we going to develop those data? How are we going to share those data if we are going to? Who is going to pay for those data? People before were saying that those sometimes getting data is basically, it comes with the project. You need data for making decisions. That comes with the project, so it's relatively easy. But sometimes you have what we can call intermediate data that is mainly not really an outcome of the project, but it might be useful for some other things, but because it's not a real outcome of the project, nobody is willing to pay for it. So how are we going to do that? I don't know. Maybe you can share your experiences a little bit.
I complicated. I will start with this issue. As you mentioned before, the tunneling, the tunnel boring machines have a record, but normally this record stays in the construction site, in the administration site. It's not public. You will not have access to it because confidential data. Sometimes it's included in the contract. Very tight clauses to it, and that means for the TBN operation, I will call dream, that in the future the TBM will be automatic data driven. It's not so close. It's not so close because this lack of access to data. We think now that maybe, for example, one of the biggest manufacturers, Hernet, have his own cloud, they collect data and so on. Maybe they have this possibility, but I think companies like my company, Senent, have very limited access to this data to develop fast and with let's say with material to develop. Right now is very easy. The other point is, for example, public data from satellite. We use in-share information right now with another research development. The data we collected in the tunnel with the leader is our data sharing with the metro carrier. This is the other way. We have to move forward to get the data if don't have the possibility to get with the TV manufacturer or coming from the other sources.
Okay. So I agree with Carlos, and I'm a little bit on the other side. In fact, we have been having these conversations with Senent in the past. It's tricky because we, for example, in Ferrovial, we are not developers. We have some internal tools, but in the end, we are not developers. We are elephants compared to startups and smaller companies that can go faster and develop. But in the end, as Rafa was saying, our data is our knowledge. So and it's becoming more and more important to keep that data to yourself if you want to have that competitive advantage. So it's kind of trying to balance the data that you want to keep internally because it gives you the most competitive advantage, but then at the same point trying to find what data you can share with external parties that is not so relevant maybe for you internally, that can help other companies to keep building and to keep having that. So what we are seeing is sometimes we see solutions that are very, very good, like the ones that Senent is developing, but either you have a specific contract with that company to work only with them, or I mean, but sometimes it's hard to have that in all your projects. Otherwise, it's a problem that doesn't have like a very easy solution, but at some point, or we start to be more open about some things. Otherwise, we're going to get stuck at some point with the developments. So it's trying to find that balance.
Data can also be fog. So it can be clear, clarifying, and it can also constitute a cloud that doesn't help you to see. It could help the machine, but it doesn't help people looking at the data. But referring to that, we need protocols to establish what has to be shared and what doesn't need to be shared. Keep in mind that tunneling involves very expensive judicial processes when things go wrong. So if you publish the data immediately, if you've seen The Martian, the movie, or read the book, NASA has to publish everything within 24 hours. So if it processes a picture, it has to be public in 24 hours. That's an extremely stringent request. And public and private companies will not want information published that can be used against them in court. Both public and both owners, and contractors. That's one problem. The other problem is with tunneling boring machines is a very centralized operation, and you don't have really through subcontractors. You do have them, particularly not in road tunnels or in railway tunnels, but in hydropower. In hydropower tunnels, there is subcontracting of TBMs, but really it's not that much. But with conventional NATM methods, you get all sorts of people involved in the tunnel. So you also need a protocol to put some order into that. So that there needs to be, right now, it's like the Serengeti with all sorts of animals around, and everybody does what they want, what they can. And the other thing is, the model could be that you feed the data into machine learning, but you don't look at them, which is a different thing. And it may develop in what I call the Gaulish village, the Asterix village, in which you have a druid, and the druid tells his secrets from his mouth to the ear of another druid, but not to the general public. So there's things that would need to be looked at and put some criterion to that.
Yeah, I think that all those comments are, of course, very understandable. You know, I think at the end, society works as it works. There is liability, there is competition, there is etc. But Lina, maybe you can talk also from a more academic view. No, we are in the university. We have probably a different framework, and you know, just to let you introduce a different, I'm going to play a little bit of as a devil's advocate. No, I don't know to what extent this approach of keeping data for ourselves is not going to at the end make us to develop the wheel many times. You know, because Ferrovial will develop their own wheel, and then Acciona will develop their own wheel, and then somebody else, and then that's definitely going to slow us in the progress, right? And if you look how other like fields of knowledge, computer science, that basically have been developing these tools, for them it's very important to publish their data, and they have public database from an academic environment. For instance, you can get a publication out of a database. You know, you have new data, you publish it, and that's very important in your city, etc., etc. So I don't know, Lina, if you can maybe talk a little bit about your views on this topic of data, how we can deal with it, please.
Yes. So yes, I agree with the last intervention that there is a big problem sharing the data and how we can share this data. And there are a first step, sharing the data with all the stakeholders involved in the consortium. It's a first step to do, because sometimes in this consortium it's not easy, this sharing of data. And at the end, we are dealing with an image that we need to exploit with some tools to get access to this information. So this is not a very practical use of this data. In another side, we are now dealing with a new generation of students that need to use these new technological tools to analyze the data. So we need to do formation for that, and to have this possibility, we need real data, because for the moment we are using a lot of synthetic data, but the best is to have this real data. So maybe one possibility could be to have some database with anonymized data. And in that case, we are dealing with some shared data, maybe from previous projects. We don't need to really the projects of this moment, but with some previous project with anonymized data can help us to get access and to propose to this new generation of students to practice with this data.
Yeah, I think that's an excellent idea of maybe working with anonymous data in the future. Maybe, I don't know, the public sector can push in their projects to make data public. We don't know. But there is going to be an interesting debate in the future about it. I don't know if anybody in the room may want to share their comments, thoughts, experiences based on data. And I see a lot of people which I know for a fact that they are working in these topics. So please, I encourage you to participate. If you want to talk in Spanish, that's okay. We will translate, no problem. it looks just as if we were in the classroom, right? We have the students and, and nobody.
I
nobody
will say
talks.
one thing, just a note of what you said. Don't take it for granted that public authorities will be much more interested in publishing data than private companies.
I know. For
reasons,
liability, we'll
for
talk about
different reasons.
we'll talk about liability right now. But I was thinking more. Let's say, I mean, before I'm sorry, I don't remember who it was, but we're saying, okay, having data or information about geotechnics is very important, right? So in some places, you know, I don't know, the administration is say, okay, I make that every borehole that is conducted in my city, for instance, goes to a public database, or every site investigation information. That's something that, you know, probably liability related to that is much more limited. Maybe there is a direction.
That already exists, the public databases. I think that is an example of information that we could share easily. I think my point of view, from the last 10 years, when we started with BIM and all that, there was like need for sharing the information. Everybody was very open to start sharing the information to being more transparent. But with the AI wave, things have gone like the opposite way. And now I think both in companies and the public clients are quite scared of what is going to happen in the future with that data. I think that is why there's like the opposite wave now. We don't know how this data is going to be used in the future. So we better keep it. And we're also a construction sector, which we are very traditional, very hard for us to change.
And then, of course, there is also an issue which I wanted to introduce, because this leads us to what I wanted to make the second. I mean, we don't have a lot of time. The second main point of discussion, which is about how to design. I mean, we have been talking about how to predict, but they were like, I know, my talk, Lina's talk, other talks. I mean, they were advanced in the sense that we are using relatively advanced tools, but still we are not really talking about full designs. No, we will get to the point in the future in which people will want to make almost full designs based on artificial intelligence, machine learning, etc., based on data experiences. And this raises a lot of also things to debate and discuss. No, I mean, who is going to be liable for mistakes? Lina was talking about it. An engineer signs a design, and then he takes full responsibility. Can we really trust what a somewhat black box model coming out of, you know, artificial neural networks, etc., which we don't really know what it's doing, tells us to do? Or do we have to put some engineering judgment to decide what to do? And in that case, how are we going to make sure that people have been trained based on basically data can use that or can correct the outcomes of an AI model? You know, I wanted to introduce this idea so that maybe also again you can discuss. I don't know, maybe Lina, because you were the one introducing the idea of responsibility or liability. I don't know if you want to start this round of discussion, and then we'll continue with the floor here.
Yes, of course. Yes, this is an interesting point, because in my experience working with some industrial, when I propose to use machine learning, I always have a first no, because people is not confident with this black box. This is why we are now trying to do some works more related to interpretability and transparency. But I think the big question here is to how to train again the new generations without making new generations that forget the expertise in the field. Because in tunneling and in rock mechanics and soil mechanics, we are really in an empirical domain where we work a lot with expertise in the field, and each case of tunnels is really unique. So it is very difficult to generalize. And the question is what we need. We need data scientists and mathematicians that will work in our projects, or we need geotechnical engineers that can be able to use these new tools to understand the data that we are recovering from field, and then do some predictions for the future in these specific projects or for future projects in similar conditions.
Thank you. I don't know, maybe Manuel, you have designed a lot of tunnels, so maybe you can share your.
I think that, somebody wrote that all models are wrong, but some are useful. So, but basically, that's a very extreme statement. What I usually say is that models are a simplification of reality, and the question of a model will be useful if it answers the right questions, the questions you want to be answered. So if you try to imagine the far future, you would use these tools to automate tunnel construction completely. And you would need to give a very complex set of rules to know the machines when to proceed and when to stop. It's not easy. If you think of a standard tunnel and you say, okay, take all the people out, which less risk in many ways. But that's one goal. We drive for automation. We could also drive for variety, not in TBM, not as much in TBM tunneling as it is today, but in standard tunneling, you could use the new Austrian tunneling method used to be called the three lies. It's not new, it's not Austrian, it's not even tunneling method. So, but the basic of that would be use a different support for each different ground type. How would you define different ground types? We simplify that into type 1, 2, 3, 4, and 5, and fault. Generally in design. But you could explode that. You could say, oh, we have 1A, 1B, 1C, 1D, 1. You could take that into 30, not 5. And with machines, it would be feasible, because with people, it's not because of the learning curve. You don't respond fast enough to changes. But you could do that, and you could use the data to deal with that and have very different thresholds.
Yeah, that was a very interesting point. But before I will give you also an introduction of a new idea. No, you were saying that all models and ROMs are useful, something like that. No, it's true. But traditionally, like a tunnel engineer at least knew what type of model he was working with. So basically, if you have an elastic model, it can be good for a granite tunnel because it's so strong that it's not going to plastify. Or that if you want to simulate like very large convergences, like Lina was showing, then you need some type of at least plasticity, and then maybe if you want to model like evolution with time, some type of rheology, for instance. In this case, we don't always know what type of assumptions, let's say, there is behind our models. We have to be careful a little bit with that. And then before I introduce you, like there is another key issue in my opinion, at least with my experience. You go to ChatGPT. I'm sure all of us have gone to ChatGPT, for instance. I'm not sure if we have published a lot on phase stability. And he told me this experience. Would you go to ChatGPT with one of the charts in our papers about phase stability? And he tells ChatGPT, okay, what are you seeing in this plot? He gives some explanation. Oh, I see an axis, horizontal axis, vertical axis, blah, 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 blah. Then you provide a little bit more information. Okay, this is a graph about phase stability, conditions of a tunnel, etc., etc. And then ChatGPT comes back, very assertive, and tells you, oh, yeah, of course, horizontal axis is quality of the rock mass, vertical axis is the pressure that you need to pull, I think it was, from the face. And then Salvador tells him, it was his work, his PhD. He knows very well what is in the plot, of course. And he tells, it's wrong. Actually, it's the opposite way. But then ChatGPT comes back and says, no, you are wrong. Because blah, 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 it gives you like a full assertive response, which if you are not an expert, truly expert, because you have developed that plot, you might not be able to say you are wrong. And it's a little bit scary. You need to be careful of that. Oh no, you want to elaborate a little bit?
Very brief. One of the problems of this in all fields is that we're losing the experts and we're only having computer experts. So tunneling experts are people that have seen and that happened. I mean, I'm old and I've seen too many tunnels because of I was lucky and I was there. But there's people I've talked to people that have been in 10 years building the metro line in the city. And they say, I have 10 years of experience in tunneling. No, I have 10 years of experience in one tunnel, which is not nearly the same.
About this point, I think it's at least it's our responsibility as technician, engineer. Be critic with the ChatGPT, Copilot, this kind of agents, because in my experience, what I see is the quality of the information you receive from the agent depends directly of the information and the data you introduce in the agent. That means that the first act is by us. We introduce the information, we introduce the question, we introduce the prompt, we introduce the first step. If this first step is not the best, let's say, developed, the answer will be completely crazy. Could be completely crazy. It sometimes could be more accuracy, sometimes no. But I think we must to be very critical with the first critic with the answer. Don't accept the first answer. Don't say, okay, this.
Yeah, that was my point, basically. We have students here in the room.
Yeah. No, because I'll tell you, I'm using I think Copilot since May, April, constantly, and this tendency is this trend is very clear. If you introduce for example, a prompt with 2 lines, give me this, no. The answer could be, imagine, it take information from there, mix everything and say, okay, this is the answer. If you want to keep with this, okay. But we don't have to keep with this. We have to be more proactive with the agent, push the agent. For example, I in the past I was in the side of the contractor, and always tell me push the subcontractors to produce. But this is the same. We have to push the agent. Don't stay with the first answer. Don't stay with the first interaction.
Thank you.
Yes. Okay. So I'm going to relate to my presentation. So I've showed you many use cases that we're doing in the company with AI. So let's be clear. That percentage is never going to be 100%. So we're always going to need the person behind. We have many experts that are retiring, as I said. Those people have been in different channels, not only one. But we need to make sure that we can transfer that information, that knowledge to the next generations. So for me, the AI today is an assistant, okay? So it can help you go faster, but you always need to review everything. And in fact, in the construction places, it's, I mean, we have so many risks. So we are changing the risks of the project and adding the ones that we're coming from the use of AI. So this is gonna be a game changing in our culture and how we build things. But let's not go crazy. All technologies have like the peak and then it's coming down. So I think with the AI, we're seeing everybody's using it and we're seeing the benefits, but we're also seeing the risk and what is working and what is not. So at the moment, the AI is not able to think as an engineer, is not able to understand the 2D drawings, is not able to understand a 3D model. If you would need to input the whole university degree inside the AI, all the books, all the information that we study, And then, of course, the lessons learned and feedback from our, so we would need to replicate a brain of Manuel or somebody. So it's not, we're not there at all. Okay, so just treat it as an assistant. We have a lot of benefits because we do a lot of administrative work and repetitive work, and that is where the AI can help. But there's always going to be the need of a person. Today, this changes very fast, but let's hope it is like that for many years yet.
Okay, thank you.
There's going to be another thing, another aspect of the artificial intelligence, and that is it will be available for those who pay. Because right now, ChatGPT is using different time limits for different fees. So if you the free version, you cannot produce a 15-page report because it will cut the task before producing it. So it'll have you 3 days saying, oh yes, I'm going to do this. Oh yes, I'm going to do this. Oh yes, I'm going to do this, and it won't. But you have to pay. But if you pay $200 a month, then I think it maybe it does. I haven't tried. But there is limitations. And of course, what you said is right. Use the artificial intelligence to help you. Don't ask it to do your job. Because if you ask it to do your job, if it does it well, you'll be fired. And because they'll find out. And if it doesn't do your job well, you'll be responsible. So it's just not a good idea to tell. Many students do that. Many students just put the prompt of what the subject asked. Oh, this task, yeah, do it. But of course, the difference between a student and a professional is a student, whatever the age, never cares about the quality of the product. They don't mind if it's a shitty product, but a professional should care.
No. Yeah, thank you. I see Lina wants to add something. Please go ahead.
Yes, I totally agree with Ines in the fact that there is some the artificial intelligence is here for help us, and you should keep in mind that these tools are trained in data. But if you don't understand the data that you are using, you don't know if these tools will give you a wrong answer. As a lot of people say, garbage in, garbage out. So if you put inside corrupted data, then you will have a prediction that will have a lot of mistakes. So you should keep in mind that you need to understand the data that you are using and why you are using these digital tools to help you. Don't to do the things for you.
Okay. Thank you, Lina. I'm very happy. I see like somebody from the audience that wants to ask something, please.
Well, very interesting discussion today. And this is not a question, but more like a comment or inspired thought. I think like any tools, design tools or whatever tools, AI, digital twins, they are just tools. They are only as good as how good you use it, how you want to use it, how much you allow it to drive your project. I hope we don't come to that point one day. And then it occurs to me that we can go really extreme, like we don't use AI at all at this scale. We can go very extreme, AI will take all our jobs. But when we think about future, we need to deal with the fact that we somehow, to some extent, we don't know to what extent, our children, they are going to work in a society, have to work with AI, with the society. Their AI will be playing a role in there. The thing for us to think and to do is, how do we build that into the education? To what extent we allow those data to be so open, we allow all those insights to be shared among us. So the future generation, they know what to expect what AI could do, could help. But if I have this really interesting discussion with one of the software developer, I'm not going to say which software. So he told me that all my clients come to me and say, I want this feature and that feature that I built for them. But academic, the professor, they come to me, they say, I love this software, but I want to know what's in the black box. How did you exactly, why I input this, you come to this conclusion. So the knowing how it works, I think is more important than how to use a tool. And that's what we should be teaching in university, how to think, so we can adapt with whatever the change revolution coming our way, because we know how to deal with the tools in the future, whatever new tools will come after AI digital twins. So that's my thought.
Yeah, that's very important. I completely agree with that. It makes me very happy also that you introduce the idea of the importance of the fundamentals. No, like sometimes students want to learn tools, and sometimes they forget a little bit about fundamentals. And in relation to the question of how to introduce AI into education, I think nobody better than the director of our school could answer that, but probably he's not here for that today. He's here to close the session. So I think we are a little bit behind schedule, so I think we'll close the session now. Thank you all for participating as an audience or contributing with lectures and opinions and comments. Yeah, I hope we can repeat this in the future. I'm sure the techniques and the tools will be very much more advanced, and we will have more answers than questions. Thank you.
So my name is Jose Miguel Atienza. I'm the director of the School of Civil Engineering of this school. I think that after my speech, you have a small lunch, so I will be very short. Just a couple of ideas. Today we have once again confirmed that when we combine our tradition with our capacity to innovate, we are able to position ourselves at the forefront of civil engineering. Our school has always had a strong tradition in tunneling. This is no coincidence. For decades, we have trained the engineers who have designed, built, and managed some of the most important underground infrastructures in Spain and around the world. Our contribution to underground engineering is a hallmark of our identity, part of our academic and professional DNA. We are heirs to an extraordinary technical legacy built with rigor, talent, and a deep commitment to society. But if anything has become clear today, it is that tradition alone is not enough. Engineering is undergoing a profound transformation, driven by digitalization, data, advanced sensing, and artificial intelligence, and it is our responsibility to lead that change, not to follow it. Digital twins represent one of the most powerful tools of this transformation. Their ability to integrate information, anticipate behavior, improve safety, and optimize the management of underground assets places us in a new paradigm, a paradigm in which it is no longer enough to build infrastructures. We must understand them, communicate them, and anticipate their future. Today, what we have seen is that how this technology is revolutionizing the entire life cycle of a tunnel, from planning and design to operation, maintenance, and strategic decision-making. Our school fully understands this challenge. We have the talent, the research group, the laboratories, and the network of collaborations with companies, public administration, and other universities required to become an international reference in the field. But above all, we have something even more important, a clear vision that we need to go in this direction. Digitalization is not a trend or an add-on. It is a new way of doing engineering, and we want ourselves, the engineers who lead the sector in the coming years, to have the skills to thrive in this new environment with competence, creativity, and responsibility. I would like to thank all the speakers, moderators, organizers, and participants, to our friends from France, from École des Ponts, to ITU, to BME, our partners in this European project. It has been an intense day of exchanging ideas and experiences. and also a building the future. I am convinced that new lines of collaborations, new projects, and above all, new questions will emerge from this workshop, because innovation is born from curiosity and non-conformity, two values that we proudly cultivate here. Let me end with a personal conviction. The future of tunnel engineering, the future of civil engineering, will be digital, but also profoundly human. Human is the fullest sense, able to integrate technology with expert knowledge, but also sensitivity, safety, sustainability, and service to society. At our School of Civil Engineering, we will continue working to lead that future, and we will do together with you. Thank you very much. Congratulations.
So thank you very much for the kind words. I think we are not building the future, we are digging. Okay. So now the event is closed. Thank you very much. You can go for the lunch.